interesting and important keynote here in the beginning of the day to start the day. And some of you might think, why are we starting like this? Starting on a very particular note. So before I said something about digital data systems and these AI tools that we're using, that they are not just new tools, but they're also constituting like human-made spatial architectures, meaning that what we're creating when we're creating these tools are data and AI-based environments that can either empower architects in their work and the humans in the spaces that we create, but they can also, and of course they can support our well-being and quality of life through these data systems, but they can also, and it has been proven many times, we can also support controlling, datafying, classifying, surveillance, and can have predictive characteristics, supporting more, you could say, authoritarian architectures of space. So we see a transformation of power in society through these architectures that we're using. And so this is why, of course, I'm very excited to have someone like Julia Engren here. Julia Engren, our first keynote speaker, is the founder and editor-at-large at Markup. It's a non-profit newsroom that produces data-centered journalism. And before that, which is probably where she's also really well known, is from her investigative journalism that she did with teams at ProPublica and the Wall Street Journal. And she is actually also a winner and two-time finalist of the Pulitzer Prize in Journalism. And of course, I have to emphasize here that Julia Engren's work and her team's work on making visible some of these power dynamics of these data architectures that I have been referring to today have been really fundamental to creating these more ethical awareness in society, reacting with more reflective ways of building technologies. And for example, some of the things that she will be talking about now is some of the examples and case studies particularly on machine bias are still used as some of the most important case studies to show how these technologies and these architectures that we're creating with AI and data infuse can be both big opportunities, but they can also threaten our society in certain ways. So please, Julia.
Thank you so much. It's really great to be here. I'm a journalist, and I really don't know anything about architecture except that I did want to be an architect when I was in elementary school, and I drew little plans of like what I thought my house should look like. But I then quickly moved on to other things. So I want to talk to you about my journalism has really focused on algorithms, AI for the past decade and sort of the impact they have on society. And so I want to talk to you a little bit about what I've learned in that process and how that might apply to what you guys do for a living. And I think that I want to start with the very simple idea, which is that artificial intelligence is really, at the very base of it, is a way for computers to look at data about the past and try to determine what the future will be. And so in some ways, it is absolutely just encoding the past and making it, I have this, sorry, no. So it's just encoding the past and making sure that that is what the future looks like. So in some ways, artificial intelligence is basically doesn't allow for a creation of a new future. It creates the future that looks like the past. And I'm going to show you what that looks like. But first, I'm just going to tell you a little bit about myself. I grew up in Silicon Valley, and I started coding in 5th grade. I actually, my parents were both in the computer industry, so I very much was a digital native before there was a word for that. And I really actually thought there were only two professions you could go into, which was hardware or software. And I thought software was more interesting. And so I was working in software, but I fell in love with my college newspaper and decided to go into journalism, even though I had a degree in math and computer science. And then eventually I found that I was the only journalist in the newsroom who had a math and computer science background. And so I ended up writing more and more about technology and the impacts of technology. So I was at the Wall Street Journal for 14 years, then ProPublica, and then I founded a newsroom called The Markup that's a nonprofit newsroom that investigates the impact of technology on society. And at ProPublica and The Markup, and even actually at the Wall Street Journal, I have really done a lot of investigations where we use engineers who are in the newsroom to do big data analyses of technological systems, of AI systems, to determine what are they actually doing. Because as Gray said, they are black boxes, so you can't actually tell generally what's happening. But we do these investigations that are oftentimes a year long with an engineer and a journalist, or maybe several engineers, to try to see what are these systems actually doing, what are their impacts in the real world. And so I want to talk about I was going to also mention that one of the impacts we studied was privacy, which is obviously surveillance. And after studying privacy, where I did a series at the Wall Street Journal and a book, Dragnet Nation, I realized that the next evolution was to talk about all that surveillance data, now that it's been collected, how is it being used against you? And that is where you get to artificial intelligence, because that's essentially the reason we have artificial intelligence is because there's finally enough data for computers to analyze. So I want to talk about one study because I think that it embodies a lot of the lessons. And so this is a study on a crime prediction software that I did in 2016, and it's an algorithm that claims to predict whether somebody who is arrested today will go on to be arrested in the future. This is used software across the United States in multiple jurisdictions. And there are many different brands. So I analyzed one called Compass, but actually almost every state in the nation uses this type of crime prediction software. And it gives you a score based on a questionnaire of like how risky they think you're likely to be, and judges use that to determine whether to let you off out for bail or to keep you incarcerated until your trial. They also sometimes use it to decide the length of your criminal sentence, and they also use it to determine parole. So it's used at all different stages in the criminal legal system. And when I looked into it, it had not been independently studied. There was a bunch of analyses that said that the people who made it had said it was really fair, but no one independent had analyzed it. So I went and did a public records request in Broward County, Florida, for all of the scores that had been assigned in a 2-year period. So it took a couple months to get the data. We got 18,000 scores of people who are arrested and assigned a number. And the very first thing I did, because as you may know about the United States, our criminal system is, very much biased against Black people. There's just, our jails and prisons are overpopulated. So I wanted to look, was there a difference between white and Black defendants? And what you can see in these charts is that Black defendants were getting a very evenly distributed set of scores. So 1 through 10, they were getting all, pretty regular distribution. But all the white defendants were getting low risk scores. And so the question that arises there is, well, was every white defendant actually Mother Teresa, and they were just literally the least risky people on earth, or were these scores wrong, right? You don't know. So we had to go and look at every single one of them's criminal history to see, did they actually go on to get arrested again? Because this score claims that it will predict whether you're going to be arrested again. So we had to look up every one of these 18,000 people's future criminal activity in the public record system and add it to their data and see what did it look like after we had checked. And we had to throw away a whole bunch of scores because some people hadn't been out for 2 years in order to check if they had been arrested in 2 years. And we did a statistical analysis called a logistic regression and showed that basically there was bias. So if you had a white and a black defendant who had exactly the same characteristics, right? They were the same age, same gender. Black defendants were 45% more likely to be assigned a high-risk score than a white defendant. And that's a very significant difference. And what that looks like in reality, when you broke it down even further, was the score itself was only 60% accurate. And I just want to add that, like, if I was 60% accurate in my job, I would be 100% fired. But in this world of prediction, people accept the 60% number as sort of successful machine learning, which I would say shows that the field is not fully evolved. And so the times that it was wrong, the 40% of the times it was wrong, it failed differently. So for black defendants, it basically over-predicted criminality, and for white defendants, it under-predicted criminality. And so this disparity of false positives and false negatives was the true harm of this disparity, which is that black defendants were just always getting over-predicted as being criminal. So what does that look like? So I went and knocked on the doors of all sorts of people in Florida who had been scored by the system to see what does this look like in real life, right? And so I found these examples of these two people who had been arrested for the same thing, which was petty theft, essentially shoplifting. And Vernon Prater was given a 3, a low risk score, and Brescia Borden was given 8, high risk, super high risk. And what was their backgrounds? Vernon had actually been in prison before, had already had 2 armed robberies and an attempted armed robbery. So he was kind of a career criminal, but he was white and he got the low risk score. And that was a wrong score because he went on to do a even bigger robbery, grand theft, and is currently serving a 10-year prison sentence. So that was a totally wrong prediction. And then Brescia Borden, also a wrong prediction. So she had 4 juvenile misdemeanors, which they're sealed records because she was a juvenile, so I don't know what they were, but for sure a misdemeanor is not an armed robbery, it's something small. And she went on to commit no additional crimes. And so this is what that disparity in false positives and false negatives looks like in real life. So when you look at this idea that why is this algorithm over-predicting black criminality? The answer is actually really simple. If you look at America and say, how am I going to build a system to predict who's going to be arrested in the future? The answer is always going to be black people because we know that our police system over-polices in black neighborhoods and black people are arrested for crimes that white people are not arrested for. This is very true. This has been true with drug crimes, with all sorts of crimes. And so honestly, if somebody asked me to build a crime prediction algorithm, that's what I would do. Now, the thing is that they don't collect race data in this. When they ask these questions, they say that there's no race information. And so they ask a whole bunch of questions and say that this is a race-neutral algorithm. But the reality is these questions have what they call proxy variables, meaning they ask, has anyone in your family ever been arrested? Has anyone in your neighborhood? Is there a lot of crime in your neighborhood? All of these types of questions tend to be able to sort you even without saying what your race is. And so for years, until I did this analysis, honestly, the people who made these algorithms said these were totally race neutral and not biased in any way. And so the reality is, though, that that is exactly what I'm talking about with an algorithm that encodes the past. What this algorithm did was it took the past and looked at it and said, oh, the past looks like black people are always getting arrested. So I'm going to make an algorithm that predicts black people will get arrested. So in reality, the computer's doing exactly what it was asked to do. But I think it's important to think about whether we really want that in every situation. Do we always want our predictions to be based on the past? Or do we want to actually create a different type of future? Because we see this is not just in this algorithm. I'm sure you've heard of some of these stories, but for instance, you may have heard about Google's image recognition algorithm, AI algorithm. So what it did was it automatically tried to guess what was in your photo and then tag it. So like if you had a picture of a duck, it would say it's a duck. And then it was found tagging photos of black people as gorillas. So basically, it was this huge flap, and they were like, we don't know why this happened, oh my gosh. And then years and years of investigation, and what they found was that the data that they trained this algorithm on did not have a lot of black faces, and because they just didn't think about it. They just had a bunch of pictures of white people, and then they were like, also the only black sort of facial things in there were gorillas. So their solution was to remove gorillas from their database, which is also an idiotic solution. And so this is exactly what I'm talking about, was like when you use the past, you have to be really careful about designing what does that past look like, because you're going to recreate it. And if you don't have any black faces, but you have gorillas, that's what you're going to end up with. So now today, things aren't really that different. So there's this new program out there, this fancy image creation AI called DALL-E, which I don't know, has anyone heard of DALL-E? Yeah, so it's everybody's super excited about it. It creates images that, supposedly you wouldn't think of. And so there's a website called Hugging Face, which I recommend you go to if you want to check out things like this. And they actually have an analysis of like, here's what these AI programs show you when you do, when you look for things. So you can put in ambitious accountant, and I put in emotional baker. And guess what? It's incredibly gender biased, right? Like there are no male bakers and there are no women accountants. And not to mention, I don't think there's any people of color in there. And so this is what is the current state-of-the-art AI is still showing us, which is basically some sort of calcified vision of the past that was based on stock photo imagery, essentially. And that is what we're creating. So what I found in my research on these scores was that when I talked to scientists and computer scientists about this bias, they said it's mathematically inevitable. Like if you have a system that's biased and you feed it into the AI machine, you will get a biased outcome. And so this simple, very obvious insight is one we're still struggling with in the AI sector. And so I think I want to just leave you with posing this question as people who job it is to create the future. How can we do better, right? Because you guys are in the business of creating the future, and you're not going to be able to avoid using AI, I think. So let me tell you a few things that are helpful that are out there. One thing is something that is an effort called data sheets for data sets. So this is basically the idea that the data sets themselves need to be labeled. So for instance, the one with no black faces and gorilla faces, it should have had a little label called, this is a data set that has no black faces in it. And just the way you would label the ingredients on any kind of food. So that is one effort being led by a computer scientist named Timnit Gebru at an AI institute in California that I think is worth checking out if you're going to use AI. Another thing is there are all sorts of people out there who are trying to do algorithmic fairness assessments. And there's a conference called the Fairness, Accountability, and Transparency and Machine Learning Conference that every year they do competitions to see who can better analyze the fairness of an algorithm. And then there's this idea that we have to audit the outputs. So even if you can't see the inputs and the data sheets, and maybe you can't examine the algorithm, you can look at what is the impact, what are the results of it. And so there's a whole movement towards auditing. And there's a woman named Joy Buolamwini who led the research that showed algorithmic bias in facial recognition systems. She's an MIT computer scientist. And she has a startup called the Algorithmic Justice League. And they actually offer bounties. So they pay you if you if you do one of these studies and find algorithmic harm. And so I just want to say, as somebody who's not an architect, I was trying to think to myself, what does it mean if you focus only on the past? And it makes me think you would not create innovative architecture. And maybe this doesn't count as innovative to you, but I have to say I was really moved when I went to this Holocaust memorial in Berlin. It is not something that I imagine an AI system would create, right? It doesn't automatically think like, oh, I want to be inside long concrete blocks that are standing upright. But it was an incredible transformative experience, and I do think that that is the power of humans and human inventiveness. And so I think that we have to always remember that we bring the future, the computers bring the past. Thank you.
Thank you. Let me see. Is this one on? No. So I'll go here. Thank you, Julia, and wonderful ending note about the human power to do unpredictable things, probably. So we are moving on to the first session. So this was, of course, a very important reminder to start the day off. We'll move on now to look more into details of this kind of more tangible technology, how we can use architecture or use AI to support the architect's work, in particular in urban planning. So how it transforms work processes and design. It can, of course, importantly transform the methodologies for urban planning, and it can help reach sustainability goals, but actually it can also work contrary to sustainability goals. We have a set of very interesting speakers here, and I'll ask the two that are present in the room to come and join me up here, and then we have one online. We have Emmanuel Di Giacomo, for EMEA BIM Ecosystem Development Manager, Autodesk France. Then we have Ingrid Paoletti, who's online, Associate Professor of Building Technology at the Architecture, Built Environment and Construction Department of Politecnico di Milano in Italy. And we have Jiří Vítek, architect from Uon Studio, Czechia. And maybe if someone can make me... Okay, it works. Okay, so at first, could I please let me sit a little bit closer to you? You're sitting all the way down here. So at first, let's have Giacomo, or Emmanuel Di Giacomo, who will have a presentation for us to introduce the first part of the topic. Would you like to sit here or go up there? It should be, if you put it closer.
Hello, test. It doesn't work. Sure. Yes, sure. Thank you. Hello, everyone. So, yes, indeed, I'm going to make a presentation, and so about the power of AI for the creation of cities and smart planning.
No, I was, if you would like to present the topic.
Yes, okay.
Yes?
So I'm going to go.
Yes,
Okay.
yes.
Cool. Sorry. Okay, so hi everyone again. So yes, I'm going to introduce the topic, and I'm going to speak about the power and the importance of AI and digital. It really helps architects to build a better environment. So thanks to also these kinds of approaches, we can definitely meet the current challenges that we have as architects and urban planners, especially with which regards sustainability. there is a critical need and also a huge opportunity to be more efficient than what we used to be, you know, with traditional techniques in order to create cities which are more carbon neutral, and also to create a better, finally, a better world. What is interesting is that AI, BIM, and digital trends, generally speaking, these tools and these approaches and process can definitely help not only create but also accelerate the creation of this new world. So what is obvious is that current methods are currently insufficient and very manual. We all know that. We are not able to kind of anticipate based on facts and numbers as AI can do it. There is currently no decision tool, and there is a lack of analysis because we are not able to combine the way we design buildings and cities with some predictable and tangible data, like data coming from meteorological stations, for example, or the future consumption of buildings or cities, and this is very important. We need to have this data. The word data was mentioned several times in the previous conversation presentation, and it's really important. Also, it's very difficult, and also in terms of city planning, it's very difficult to communicate the future aspects and the future geometry and the way people will live in cities, because generally it's a kind of 2D work, and thanks to these kinds of approaches we are able to communicate more efficiently. Then after, what is also difficult is the way you combine this with the use of other applications like BIM software or whatever. What is the follow-up when you start creating, manually speaking, and how do you transfer this to the various different kind of application? And then after, what is important as well is to, out of all the aspects that we manage as architects and urban planners, is how we use the data that comes out of this project in order to be more efficient, and also think about the future operation and maintenance of these cities. And last but not least, it's also important to mention that currently speaking, the process that we use are very limited in terms of collaboration. And obviously, one of the goals of these new approaches is to create more sustainable and efficient buildings and cities, clearly. Obviously, all the things and all the disruptions that we are living, we can clearly see them through different catalysts, which shows that the processes are evolving. It's important to note that decisions should not be made anymore on past experience, as it was mentioned in the previous presentation, but also that it's based, the decision should be made on data and on pragmatic facts that are extracted from these kinds of approaches. Of course, using an AI-based approach facilitates and accelerates the communications of this project creation. Also, using AI and all kind of sources of material, you can extract any kind of information which is going to create big data that we are going to be able to exploit as architects in order to make the most efficient and interesting proposals. So not only from a geometry or a perspective or a space quality perspective, but also in terms, for example, of energy consumptions. And of course, one of the biggest advantages also of using AI approaches is to be able to multiply the number of possible ideas and options that you would propose to your customers and the owners based on these approaches. So pragmatically speaking, what is interesting as well is that it's going to accelerate your process of creation. For example, you can directly georeference yourself, so just by typing an address, automatically it's going to gather all the data that is necessary for the creation of a city, like for example GIS data, CAD data, BIM data, whatever it is, and it's going to automatically extrude and recreate the existing conditions. Then after giving some kinds of directions, like the kind of city mapping that you want, eventually some internal streets that you would like in a specific district that you are working on, and by entering some data which corresponds to the program of the cities, like number of apartments, the kind of apartments, etc., it's able to automatically create different options that you will use. Also, what is interesting is that you can enter some rules and geometric constraints based on the urban constraints that is defined in the city, in order to make sure that, for example, there will be enough sun inside a specific district of the city, and of course that you will meet all the requirements that were given to you by the owners or by the proprietary or by the people financing this. What is interesting to mention as well is that it's a basis for you to work, but it shouldn't be mandated for you, because it's just a basis and you will be able to completely disconnect the automatic part of it. As you can see on the screen, it's also very interesting because straight away in a live mode, it gives you all the information about what could be your next project, and you could compare, of course, different options, different variations of the same projects. It's not here, of course, to replace the architect or the urban planner. And by the way, what is interesting is that it's very interesting both for architects, urban planners, and all the professions like real estate professionals. Also, it could take into account some specific aspects like creation of parking. But what is more interesting is the analysis features of these AI-based approaches. For example, here, solar radiations on facades. This would allow you, for example, to determine where you would be able to put some solar panels on your projects. It could also help you to check the different kinds of point of views that you would get making these kinds of project, or choosing another option. You could do wind tunnel analysis, of course, to verify that it's not going to be bad for the people who will live in the future in these districts. Also, it allows you to verify things like age studies, etc., eventually heat island, etc. We all know that with all these constraints related to the environment, it's very important to master all these aspects and be able afterwards to compare. So you will really extract all the information that is necessary to do your work properly, and to have a right conversation also with your customers. In terms of 3D model environments, it will be ready to use in seconds. You will gain lots of time, obviously. Some architects use it to quickly create the built environment in order to put their project inside also. There is an effortless volume creation with parametric also and automatic design tool, as I showed you before. What is interesting is that it will free you from the time-consuming tasks that doesn't have any added value. And AI-powered analysis will help you understand the quantities of the project. And you can imagine any kind of decision based on numerous analysis, because it's based on the any kind of data, energy consumption, sunlight analysis, verifying the views, verifying that you create the right number of apartment, daylight, or whatever. You can expand this at the infinite. And AI is really a unique driver for high-impact design, and of course it will accelerate the high-quality creation of your cities. Thank you.
Thank you, Manuel. And so, yes, you can sit anywhere. So we'll organize this session in a way that we'll have few presentations, so everyone here at the panel would have a chance to provide their perspective on this really interesting topic, and then we'll have a conversation afterwards. Of course, welcoming any questions from the crowd in here or anyone online, but we'll try to put these at the end after we've heard everyone's perspectives and presentations. So next in the panel we have Ingrid Paoletti. She's online, as I said before, Associate Professor of Building Technology and Architecture at the Politecnico di Milano. And we are, Ingrid, I don't know if you are online. And so if we could have the maybe image up here also.
To authorize the video.
So the only thing is that we're missing your image.
Yeah, I'm trying to share, but he says you cannot start your video because the host has disabled it.
Okay. So we have the technicians down behind, I can see, working on it.
It's like hide and seek.
We're looking forward to see you on the screen. We can hear your voice.
Okay.
So you are present in the room in this way.
Let me try again. No.
No.
Maybe I can share in the meantime the presentation and you see me later. Let's see if it works.
That would be a good idea.
No, only the host can share in this meeting now.
Okay.
So B2 is not working.
So I can tell you that there's a lot of things going on behind. I can see running. There we go. Here we have your presentation. Unfortunately, we don't see you, but we do hear your voice very clearly.
Mm-hmm.
So yeah, maybe we'll just do it like this, and then hopefully we'll get to see you at the end and also at the panel.
Okay.
Can you try again, I'm asked?
Share. No. Can you see me now, maybe?
No, we only see your presentation.
That is coming from you.
Yeah.
Okay. Mm-hmm.
Well, for now, we're seeing your presentation, at least.
Okay, yeah. Hi.
Okay. All right. So in the room, unfortunately we cannot see you, but I'm informed that everyone can see you online. So, oh, there you were.
Okay, yeah.
Perfect.
Hi.
Okay, thank you. So we're looking forward to hear your presentation now.
Okay. I can share? No, I cannot share. I have to use yours. So I have to say next.
Yes, please.
Okay, but I also have a video from, okay, let's see if maybe later I can share. Because I also had a video I wanted to show you on materials. Okay, next we can go fast on this. Maybe, hi, I'm Ingrid. I'm from Politecnico di Milan. We work on materials and trying to merge digital and materiality. That is, I think, where it can fit in the panel. So what does it mean today to work with different material? Oh, okay, it's working. I will share.
Okay.
Because I also have a video I think would be nice to see.
Okay. Okay.
I'm sharing. You are sharing screen, right? Okay. So here, yeah. So let me go back so I can go fast. Okay. Okay, so this is our research group. It's called Material Balance because the idea is to blur the borders between natural and artificial. So the balance of matter is not only a balance of physical, but it's also trying to understand how we can better understand materiality and use it in our design. I will show you some examples. So I think this can be quite fast. So this idea of balance is a physical, is physiological, is performative, but it's also semantic. So as Politecnico is architecture, engineering, but also trying to work on a new material culture that could express our idea of today, how we can go with materials and embed them into design with softwares, with the digital. So how we can use the two together. It's physiological, it's performative, but it's I will show you some examples. I think I can switch because I think I have 15 minutes and the presentation was a little bit long. A first example, I can go a little bit deeper on this, is, for example, we start with the technique of making baskets, so weaving, and we said, can we use this technique, so trying to merge a materiality that comes from our imaginario that is quite traditional, let's say, with new digital softwares that today can help us in designing. So we try to understand how knitting and weaving works. And we made with different softwares sort of parametric design of the weaving, looking at a single tensor, two crossing tensors, three crossing tensors. And we designed through digital softwares, so parametric softwares, a new way of imagining these patterns of weaving. Then we looked at the materials with microscopes. So I think here too, it's a way of using the more we can data and digital. So how is the structure of a rattan that is used usually for baskets? How is this, its materiality really? So we discovered that it's very much vascular because it needs to take the water to be flexible and resistant at the same time. That is a very typical characteristics of wood and of a live material. And here is how you can see it in the microscope, so with the small holes. And then we embedded these properties inside the design. So I think one of the big challenges today is the more you can embed materiality in the concept and using the digital, the softwares and what you have to really know how a material will behave, the more you can enhance your creativity as a designer, and you can also perform better. So that means also imagining that a client, a builder, a user could use your objects, your design, your infrastructures. And so we designed the curves, embedding the properties of the material that we have checked with the labs here in Politecnico. We are a very multidisciplinary group, even if we are in architecture. So we imagine which one could be the control points of the different lines so that we can imagine to make our weaving, let's say. And then we make ribs that could stand and make a sort of big architectural demonstrator. We use usually this big scale that could be also in a city. We also put this infrastructure in a city or in a very big space, so we can understand how it works visually and how it can work also in performances. And this is our, let's say, rethink computational weaving. So it has these ribs, then it has the rattan that is weaving inside. The structure is given by the link between the ribs and the holes through the rattan. And so we understood how we could simulate this process and have, on one side, a bigger creativity because we knew the material. On the other side, an informed design through informations that comes from data. And this is the result. It was quite big, like 10 meters long and 5 meters high, more or less 4 meters high. And this is the main design. We put it here in Politecnico. Then we put it outside in public space, and kids jumped on it and it got broken. So it got back to its original use, let's say. So, so I think this is one of the examples I could show on this idea of merging natural and artificial. So what is, it's a natural material, yes, but we use artificial intelligence somehow, the computational micro to the macro to imagine the structure. We do the same for other material systems.
Ingrid, we're losing.
Here we made the saddle with different
Ingrid, we're losing the
understanding
connection.
where the main loads and where it can be more tender. And I will show you this is in Polytechnico. Is that the fact that you anticipate this? My voice? Can you hear me?
We can hear you now. There was a moment where you went off a little bit.
Hear me? Yeah. So this is another example where designing with embedding material properties and also constraints from the machine. In this case, because it's an easy machine, it's 3D printing, so it's not difficult to know how it will behave more than other types of machine. We really could merge together the design issues of a simple saddle with a lattice structure, putting materials where it was needed. So looking also at using not too much material and constraints, so in an idea of being sustainable somehow. This is a polymer, so but it can be melted and used again. So I think another example here is how the digital and the material together can open creativity. If we stay in a ground where we don't look only at bio-based materials, new materials, innovative materials, and on the other side to the digital, like if it was something completely different. What we try to do is really to merge the ground between the two. And this is the example. I will show you, I think, an exhibition we made recently that is here. And I will show you a video with what is upcoming, let's say. This is now in Triennale di Milano. It's an exhibition that is every 3 years. And it's called Unknown Unknowns. And I think it's good and interesting title because it says what we don't know, what we know we don't know somehow. It's a big question. How we can deal with what we don't know. And in the part I have curated, I have worked with the alchemic laboratory, scrolled, that is yellow like alchemy, because the idea is that when you use the digital and the material together, there's a big merge between natural and artificial, between the unexplored. You can really open more scenarios. The more somehow you control, you have information, the more you can push your possibilities of innovating. We have some installations. If you pass by Milan, you're more than welcome. You can also drop me a mail. And here, for example, on the left, we have made moss that makes energy only with photosynthesis. So the question is this technique, so we have studied all the process of how it could work. Is this natural or artificial? Are we working because we know how it behaves with something really natural, or it's more something that we have changed somehow? I think this is also very important today when we look at sustainability, not to be naive. So on one side, there's the sustainability, and on the other side, there's the digital where we simulate things. I think it's really important to put them together. There's another installation on the back. You see mycelium, but it's used for acoustic purposes and simulated with performances, so to look at acoustics. And I think here you cannot see it. Here on the left, we work with self-healing materials. So concrete or plastic materials that can auto-repair. And here too, the question is it natural or artificial? Is it dead or alive? Because if material that we think are dead, somehow they can close again, like they use it for the closing of the astronauts or for specific cement where they can close the cracks. So if we can imagine to tailor matter and to know with the software, with the simulation, how it will behave, so we somehow modify our reality, what does it happens at the end?
Ingrid, if you have a video, a short video, if you could show this, and then we have to move on in the program, but thank you very much.
This is the last one. This is, we are working on materiality and the digital. So how do you represent such a complex topic as matter in the digital? That I think was also the link between the other intervention today. And here we have made a simulation of a sort of ball where you can stop and move and use different configurations. You can see now it's moving randomly. And this is how you could represent different types of matter and what they represent for you. So you can stop them and you can imagine how you feel with a specific material in the digital. So this, again, to merge the senses with the physical with the digital. And I think with this I can close.
Thank you very much, Ingrid, and I hope you can stay for the discussion afterwards. So we've seen a little bit about urban planning and how AI can be used in the very planning of the space, and we now also in terms of materials, how we can use AI. And so now the last presentation is Jiri Vitek.
Is it okay now? Yeah. Cool, thank you. It's really honor to be here. Thank you for invitation. It's really nice. And I'm so glad that we have so many nice speakers. And this topic is really amazing. Because now we are in special time where we are able to use computers in many, many ways. And the most challenging thing is to use them in right way. And I'm very happy to for the first lecture because the past and future is very embedded in our minds, and the biggest problem for us is actually how we think and how I move with this button, right? Cool. So we are forcing, in kind of end of modernism, we can call it like that, and we don't have any clue what will be next. And the question could be, is it artificial intelligence able to help us with that? Let's see, right? So I really like the last movement with DALL-E algorithms and Midjourney way, and it's super interesting, super funny. And I also like the kind of very short prompts. This one was anatomy of architecture. And surprisingly, I get kind of very old tectonic system with organic patterns on it. And I was wondering, okay, what does it mean? So is it architecture something really embedded in our thoughts that it should be like this, or it's system, or what is that? And I will show you, this project is very old, it's like 7 years old, but it's the first idea how you can use computers. So instead of doing routine and hard work, you can use computer to do iteration for you. So I was kind of, not very happy with the urban design, and I was really loved with bottom-up systems as an organic city, favelas, and cities which use kind of topography and kind of self-organization systems. And this was in Studio Zaha did in Vienna as my pre-diploma. So I started to train kind of network system. So I was thinking, okay, we have different speed as a cars, walkers, whatever, people. And I start kind of agent system to provide street network. And then the idea was, okay, what is fullness and emptiness? Is it kind of the agent system which makes the streets, or it's kind of opposite? So, and I really like that computers help us to do kind of huge work. So I really like when I use urban design for kind of 2 by 2 kilometers or something, which is not able to do by hand, right? So you should really think about the rules, about what you want, what is concept behind it, and maybe efficiency is not the most important thing. Maybe there are so many different qualities, and with the power of computers, you are able to test them, right? And then I think, okay, if I have nice street work, what should be next? And I was thinking, okay, the old idea about Ferris and New York is quite democratic, is quite nice. And he set up, like 100 years ago, rules of shading, right? And in 60s, there was in LA also kind of development of the solar envelope idea. So I was thinking, okay, it's just geometric, so we can translate this geometry into the rules and run computers to give us kind of results. And the most interesting thing is that you can run it in one way, and the envelope is trying to get as much volume as possible and also as much sun radiation as possible, which means it's not kind of that the building will be shading somehow. It's trying to get for every building as much sun as possible. So it's negotiate between them, and also it creates amazing kind of spaces and very rich environment. And then we testing this idea into the airport city in Prague. It was competition. So we use this research into the application. We identify the street network provider, and we train much better the agent system to get efficient and nice kind of communication between terminals and bus stops and other cars. And I skipped the video, but we get a very nice result. And it's not necessary to build the whole envelope. You can also kind of negotiate inside the envelope, and it still has this kind of common language and common sense of the wholeness. Then I was in the fields, right? So we generate the field of the public spaces with different qualities, different surfaces. And also a very interesting idea is that you have control about all the data, what you need. So volume, prices, cost, solar radiation, whatever you need, like in SpaceMaker. But instead of in SpaceMaker, when you actually manipulate them manually, you do everything digitally. And what I really love on this is section, because it provides you so many interesting situations, and also in the pedestrian. So, but it was still kind of old-fashioned idea. It's still old kind of city. You have blocks, maybe more kind of rich, but it's still the same concept. So I think we should move forward in the thinking about what the city or the structure of the city could be. And this is the project in Ostrava. This empty space is actually waste heap, where the iron works put all the waste here, and it was burning like 50 years. And then they started to recultivate it, and it's last kind of empty space in the city. So it's very, very nice opportunity. And then I was thinking, I call it successive palimpsest. So with the data and computers, you are able to grab all the things, all what you need, and kind of intensificate or use it in the right way. So you are able to know, okay, this is kind of nice greenery, I will not build here, but there is a kind of concrete structure, so I can rise these qualities. And you think about the topology, or you can say that landscape is kind of fabric. You inform the fabric, and you can run so many analyses to get kind of folding and kind of opportunity to place a kind of city structure. Analyze it, say, okay, this is better for residential, this is better for offices. Use kind of thinking about distribution, field condition, and then use kind of topological thinking to produce discrete systems to get kind of structure. And it was still kind of parametric system, and then we moved to, okay, the idea was that you are able to 3D print all the city in the site. You don't need cars. It's all walkable. It's based on hydrogen level, so it's very sustainable. You can have kind of circuit economic system inside. So it's very greenery and very kind of sustainable. And I will skip this because then we move into the kind of gen and style gen systems, and Matthias will be much better in this. But what was very interesting when we start to train to making floor plans and similar thing. We say, okay, what will happen if we kind of merge the Baroque and the generic systems? And the result was really fascinating because the kind of boring generic typology got very, very nice moments. And now we are working into the kind of marriage of the nature systems and city systems. So we're training Mediterranean cities with the dunes, and we got very nice, this is more Daniel Boyan idea, but then we can get much more interesting moments. And that's end of my presentation. So we should not just use the tools because the computers are just tools for us. We should really think about what the city should be, how we would like to live in next 1,000 years, and I hope that we will find a way.
Thank you very much. Beautiful imagery. And I like the way this really represents what we're trying to show here is that AI is so much more than just a technology. It's a space that is being created. And when we use it for something like urban planning, I can imagine for an architect, there's so many things that changes compared to only 20 years ago or 10 years ago. And so the first thing I would like to ask you here, and I hope that Ingrid is also here still, so could we get her on the screen? But maybe you sitting here at the panel. So what if you have to kind of think of what is the greatest opportunities in terms of what was before? What are the greatest opportunities for urban planning in specific of AI technologies in particular? So Emmanuel, maybe if you want to.
Thank you. For me, so out of this beautiful presentation from Yeri, where you can combine actually poetry and data actually to obtain some results and make a more sustainable world, I think it's very, very interesting. And also you can accelerate the creation. AI is not here to replace architects, or you must combine it with our qualities, our history, etc. But I think that this power to combine data, AI, and to reduce the number of tasks that are not with added value for architects is for me the biggest opportunity.
Okay, thank you. I think the biggest challenge is to go out of the box of thinking, because the idea of the city, even what we are facing now, it's like 2,000, maybe more 1,000 years ago old. And we know now that it's not the best way. And I hope that we are able to really look at ourselves and say, okay, we are a living structure on this planet. So maybe there should be another concept and maybe another way how we can live, and maybe in better conditions.
And Ingrid, what do you think is the greatest opportunities in terms of, you were looking particularly at materials, but that can also, I assume, be applied to urban planning?
Yeah, I think it's the speed of looking at alternatives. Materials and engineers also design in any scale, I think, when you use materiality at the urban scale too. To use the IE means fastening the process of trial and error. So instead of materials usually are quite long, because you have to imagine a new material, to test it, to make labs, to see how it works. This process can shorten these phases, and so you can faster move from concept to production to construction and go back and forth and imagine new alternatives. So I think this is one of the main speed for sure. That speed is knowledge, because somehow you have back knowledge from your using AI. It's not only the knowledge that comes from the softwares, but it's what's come back to you, what it tells you somehow, and so how you can tailor different materials and a different alternative in the urban environment in this case.
So there's an interaction between, I understand, humans, the technology, the urban environment, and of course the balance. As a non-architect, I can see is really important to have a proper balance. So if we then think moving on from like what are the greatest opportunities, then what could be the biggest challenges if we think about disruption as not only something that create creativity and new opportunities? Are there also challenges that we need to kind of circumvent or get over before we can actually really use all the opportunities? What do you see? I'm thinking more also concretely in your work.
I think that certainly one of the challenges is a challenge that we face on a daily basis is maybe to have architects and new generation or future generation being trained on these approaches. Also, the democratization of technology is certainly a challenge. You know that we all mainly worked in a traditional way, so we need to embrace that. And it's something that culturally speaking, we need to be thinking about and we need to embrace.
I think it's about to clean our mind and clean our data sets, because what is also interesting about AI that it shows us how we can think and what we are actually doing, and it's a very nice mirror about our thinking and to showing what we are actually doing, and we have in our minds lots of predictions that the building should be like this and the city should be like this. And the most challenging and difficult thing is to say, okay, maybe what is the essence of that?
And Ingrid, what do you think are the biggest challenges? You talked a lot about humans and technology and the interaction.
Yeah, I think merging these two between like senses and the digital, so always trying to imagine that no borders somehow. And maybe I will also add something on considering everything environment. So what we build, nature, what we use, it's all part of the same thing. Because if we change this perspective, we don't see walls somehow. One thing is our design, our project, and then there's a rest somehow, there's something discarded, or we are some humans and somehow the discarded part is something digital that is somewhere else. If we think that somehow everything is rest, there's no discard because everything is part of the same thing, we change completely the perspective with which we can design and work in our environment.
So I was wondering if anyone in the room here, because we had some very rich presentations, and there must certainly be some questions to some of these. It's a limited how much you can say in 10 minutes, but I thought they were very rich, all of the presentations. So first let's see, and also if there's anyone online, but let's start with seeing if there's anyone in the room here who has a question to our speakers. Doesn't look like it. Did we have any online? So let's take an online question then and include the online audience.
Yes, so we have two questions online. So the first one starts with a remark. It is said that architecture is about sensibility. And so we are asked how can artificial intelligence deal with or work with the sensibility of architects? So it's about the relationships or the compatibility of sensibility of architects and artificial intelligence. So I think it can be addressed to all speakers.
That's very relevant, also building on what we're just talking about now, the relation between humans and technologies. So does any of you have, would you like?
Thank you. So I'm going to pass it to Yiri because his presentation clearly shows that you can be both using AI and be poetic. What you see also with Midjourney and these kinds of technologies, which are more based on 2D images, etc., shows that you can add some sensibility and poetry to what we are doing. But we should never be forgetting that we are architects and urban planners, and it's us, bringing these aspects. I don't think that so far the machines will be able, to bring all these aspects, and hopefully, certainly. So one of among the challenges you were asking, what were the challenges? I think that one of the challenges, obviously, this capacity of a machine, to be poetic and to interpret. But I think it's going to be challenging.
Okay, it's a very nice question. If we go into the abstract level, I mean, the machines could be much more sensitive than we are, because, for example, at the beginning, when I showed the network system, it's based on stick magic. When you have the agents, and when the agents see another agent, it interacts, and then you have like millions of these agents, and then it really interacts each other, and even in that system, it build up. So each building actually knows about all the buildings around and kind of negotiate between them. So they are very sensitive. And then it's also about the prompt or ideas what we would like to really do, because, for architects, it's not possible to make like the block and really think about all the flats, all the users, because you don't have this capacity to think about it. But if you embedded this idea into the system, into the code, you generate them. So you should be aware that, okay, in our prompt or our rules is this kind of levels and thinking, and for the kind of code, it's not problem to embed these things. So, I mean, like this.
So Ingrid, I'm going to let you get the chance also to answer this question.
Yeah. I think I will go with the provocation. Usually senses are the first contact with reality, so they give us emotion somehow. It's the first possibility with brain. We have to be in contact, and then we elaborate and everything, and so I think the digital is senses somehow, because when we look at, for example, the cell phone, it's an organ, no? It's part of us somehow. I think it's really a reality. We cannot think that there's something shared, because whatever happens, it gives you an emotion, a good one, a bad one, anxious, a stimuli. And so I think we are really, and it's the same with the design, I think. It gives you a contact with something that is the same as senses, that put you in contact with yourself and what you want to do as a designer, as a human, as a human being.
Well, so I cannot help, because of course I come from a little bit different. I don't use AI for creative production, but I work very much with policy and regulation and the democratic effects. And I can't help to think about the people and the communities that are living in the urban spaces that are being created. And so what I from my point of view, and I also see a question down there that might be related to that, is in terms of the effects on the communities when we are creating these very beautiful environments, and it looks very beautiful, but I don't really see kind of the communities, the real life, the social life, the cultural life in those. Can an AI tool and architecture, a space that is created like that, really understand in the same way, or I wouldn't say understand, but can it have the same critical reflection that maybe an architect or an urban planner or even a sociologist is, that if that's the person we want to work with as architects? I wonder how, the balance between, is there a challenge of standardization, for example? So let me ask that first, and then I'll go and see. I don't know if you're building on that question, actually. Well, is it, please, if you're building on, please.
Yes, hello. It is maybe not exactly with this question, but I got a question to Emmanuel Di Giacomo, because my name is Pascal Terracol, head of architecture and intelligent share in Paris. I would like to know what is the position of Autodesk with open data and libraries tools.
Which is actually very relevant.
This is the question, yes.
We support fully open data, etc. And this is why, so the technology that I showed, so obviously SpaceMaker is using open data, etc. And we are in a general way, when you speak about collaboration between all the stakeholders of a project, it's obvious that you need to be able to work in an open way. It's very, very important. So clearly we support open data and these kinds of approaches in most of our technologies.
So you're in an open mind and open market position, that's it?
Yes, of course, since the beginning, because we've always opened our technologies, you know, we've been the first founders with 12 other companies in the world creating Building Smart International. So the openness is in our ADN, and our technologies are open in terms of APIs, which means that whoever wants to create something on top of it can do it. So it's part of our DNA, and we know that it's important for all the people to be able to create their own algorithm, etc. And we use open data as well. So maybe answering your question, it's very interesting. So with AI and new technologies, you're able to reproduce some people behaviors like fear or joy or this kind of thing, or gathering or solidarity. So far I haven't seen any examples of someone who would be happy because he would be in a specific environment or in a specific space. So I haven't seen this being simulated, you know, with technologies, but I've seen lots of simulation around, for example, the way you would easily get out of a specific space or building or in a specific environment where there is a stadium, etc. And this is allowed and enabled by digital technologies, AI, which is able to reproduce people's behavior. Then in terms of joy or what you can feel specifically, I'm not sure that it exists so far.
And also, actually, it's a kind of game that you are able to really invite all the people who will be kind of participating in this area or city or building. And they are very invited to play with the code and make kind of curating the design, right? Because it's open code, and you can enter it and say, okay, I prefer this, and another will come and say, I prefer this, So it's not then, you know, position of architect is to bring kind of rules and code, and then it could be passed to the clients, and then can play and set up what they really need and what they want and what they desire.
Ingrid, do you have a response?
Yeah, I think also somehow there's a pedagogical approach that say that environment teaches, so the built environment teaches. You know, you shape them and they shape you. And I think in this regards, it could be to direct the values we have through this type of design or new design, or where you have different types of possible imaginary materials, so materiality is also unimagined somehow. So you design and somehow it shapes you and it can involve you and trigger your senses, your community, your values also. I think it could be also a way to arise and make more shared values.
So one thing in this conversation makes me think of, in terms of, one thing is the actual urban planning, the spaces that is being created, and how these tools are being used by the architect for very specific processes. Then if we take it further, then thinking about, you know, the background, the industry, the entire infrastructure of using AI, how are, you know, are there certain dependencies being created? Is it a creative space in general for architects to use these tools. I think I'm coming from another field, so I am wondering if it's similar in the architecture sector.
Yeah, for example, like in the metaverse, now we are trying to work with materials that has no gravity, or imagining a concrete that becomes soft, or something bio-based that is long-lasting. So I think it's also interesting because it explores new way that probably we could not reach without these tools, new possibilities of our imagination that won't be reachable without these tools.
And so in terms of dependencies, I'm also thinking, are there any big actors in this field, and what are the different technology actors in this field behind the tools that are being used by architects?
So some people use AI-based application and they don't know that they are using it, even in architectural practices, because some of these algorithms are embedded in some of the softwares. Some know clearly, for example, with AI and generative design, that they use that, you know, and it's kind of normal. It's like when you go on a website to perform something specific, it's not a problem for them. In terms of actors, if this was your question, playing in that field, in terms of creation of urban landscape, I think that there are not, I'm not going to name any kind of actors, but we are not a lot. I think we are only on one hand. And I think that in terms of image-based AI technology, like the one that you showed in your presentation, there are lots of actors, obviously, but it's more about 2D images, etc. Very sensible.
I mean, in terms of creativity, it's a super creative area. And actually there is now kind of division that they will be architects who use the tools and they don't know and they don't care if it's their AI or not. They just use the tools, right? Like a hammer. And then for us, it's much more fun to be inside and make our own software. And, you know, also about the pences, we are just free architects. You know, we have a really small team and we are able to make our own kind of software or code, and everyone actually can do that. And there are very nice movement but nearly reach digital futures who brings the very much knowledge around the world, so all the students are able to get what is happening and really learn how to code, how to use architecture and AI. And it's very promising. So there will be much more openness and freedom into the design. And it really depends on the architects which side they choose, actually.
Thank you. I would just like to add that generally even software vendors use external libraries of artificial intelligence or algorithms. Some of them, most of them don't develop them themselves, so it's interesting. And we see also lots of AC professionals, so not only architects, but engineering companies, for example, asking some support to create, as you were mentioning, their own AI software in order, for example, to create automatically laboratories for hospitals or to generate specific shapes for buildings, etc. So you also have these two cases.
Thank you. I can see there's an extra question here.
Yes, I would have a question concerning methodology, whether you think that if new technology might change how we are thinking about master planning, because of currently we are stuck on zoning, on prediction from zoning, and whether this technology might change perception, how we are planning in terms of possible regulation, whether there exist any concrete cases when this technology were utilized in some cities. A question to everybody.
Who would like to start?
It's a fascinating question because the zoning is kind of dead for master planning. And with this technology, we are able to really run negotiation in the whole scale of the master plan. So it's not just that we are much more informed because we have data, but we can run the simulations, we can kind of predict the behavior, and then the master plan can be much more precise, but also much more open. Because there was a very nice work by Manuel de Landa, The Assemblage Theory of the New Society, it's a book, and he was thinking about capacities and tendencies. And that was also our kind of thinking, because what architects actually do, right? You have kind of position that you say, okay, I have this scale of the plots, and this scale of the plots predicts it will be more residential characteristic or more, you know, retail or whatever. So then you don't decide it will be like this or this or that, because in simple rules you are able to predict kind of tendencies of using that. And then it's very interesting, even if you look at the old cities, because the old buildings didn't think about the functions. They just think about maybe architecture and maybe kind of building possibilities. And now sometimes it's not for the use which was built. It's not residential anymore. It's offices, hotels, retails, whatever. And in that thing, we can kind of rethink our approach. Instead of kind of thinking about functions, maybe thinking about capacities and tendencies and behaviors.
Yes, I don't have anything specific to add to that, but I think that out of the methodological aspect and the way we create cities, which generally in Europe are more 2D based, I think most of the time, it's definitely changing the conversation between the different stakeholders. I mean, cities, architects, urban planners. And the results that you obtain are really empowering the conversation between all these stakeholders. There has been some initiatives in Sweden, for example, and they have realized that using AI-based approaches really help make better cities, and also in terms of construction permitting, it's also much more better, actually.
And Ingrid, do you have some reflections on this question?
No, maybe no. I'm not sure on zoning. It's not my topic.
Okay. Right. So I wonder if there's anyone who had questions here, or I know that there were more questions online, or were there only one?
There was a specific question to you, Ingrid. A participant is asking, could you please explain at which point parametric design ends and where artificial intelligence steps in? Or are the two always interconnected?
Mm-hmm. Yeah, I think they are interconnected. They inform each other. I think first starts the parametric, because it sometimes drives and says something about the goals, the creativity, and it expresses the design issues. And then AI at a certain point is a sort of roots and gives more substance to possible reiterations or possible use of data or how you can move. And then it's at that point, how to handle it is the more important thing. So, but first I think it's important to have a direction, sort of driving the undrivable, they say, you know, something that is difficult because you have a lot of possible information. So it's an opportunity, but at the same time, a very big challenge. So I think it's important to use AI where you try to know more or less where you go, even if it's not deterministic. I would use, in any case, AI with a margin of undetermined patterns, because it's where magic happens.
Thank you. So here we're almost at the end of the session, but I think one thing that is really important to talk about when we talk about urban planning in cities is, of course, the sustainability goals. And I think, at least in most areas, in most sectors when we talk about AI, where AI seems to be presenting most opportunities in terms of reaching some of the sustainability goals. But of course, there's also ways that AI can, for example, with a carbon footprint and everything, have an effect on sustainability goals. But what do you think are the biggest, let's focus on the opportunities and then think about what are the biggest opportunities for using AI to reach sustainability goals in urban planning? And here I'm thinking not only about reducing, for example, energy waste and energy use, but also in general other sustainability goals, like in regards to social aspects of cities.
The social aspect is a difficult one, as we were mentioning before, but in terms of sustainability or green energy production, it's obvious that it's very powerful because you can identify the locations in the district that you are designing where you could put some wind turbines or solar panels or etc., which you could not do obviously by hand, or it would take too much time. So I think that obviously, as you mentioned it at the beginning, I think that sustainability is really one key aspect, and we know that it's becoming more and more difficult to live in our cities with the heat increasing all over the world. So being able to detect a heat island in the future pieces of cities that we are designing is really key. And if we win on that dimension, I think that the return on investment using AI will be already a big key win for us.
I mean, the first thing is that we have our prediction, right? So we think, okay, the building should look like that. But if we set the rules, for example, we would like to have as less material as possible, as much kind of volume as possible, as much solar radiation as possible, and run the code, we will get totally different, non-expected result, right? So with the computers, with the AI, with the digital agenda, we are able to find much better solution than we actually expecting or thinking of. And then, because the code is just the code, we can import so many questions into it. So even maybe social, but we should define what does it mean, social activities in the city. Maybe it could be inclusive. So it's about richness in the kind of environment. So we don't have just generic building which in this size, 15 meters wide. Maybe it will be 5, 15, 20, whatever. And then we will get our results, and then we have all the information. And then we can use the AI to say, okay, make a statistic, make a better prediction, make new iterations, like a million of them. And with this approach, we are totally in the right way.
I'll just quickly let Ingrid answer, and then I can see there's also a question or a comment here at the table.
Yeah, I think I can link to what I was saying before with this idea of embedding values through materialities. So if we use materials that we know where they come from, where they know where the resources are extracted, if we know that also from a geopolitical point of view or an economic, who has made these materials, like now inflation is so transparent, and now if we know that clothes has been done, but for us it's completely unethical, so we know it. I think it would be something similar also in construction with the materials, if we know where they are extracted, how they are produced, how much energy. And so the more you have transparency, and this is helped also thanks to the digital, the more you are responsible because you know, you are informed.
Thank you. And I see, and let's call this maybe a concluding question or remark, probably because we have reached the time for coffee break. So maybe a remark.
It's not concluding a remark, but I wanted to have last question to Iri, whether it's possible.
We have a coffee break now, but if it's a burning question, I'll allow it.
It might be a burning question because of the question is about whether there is any process of validation of what is coming and what is generated from AI tools, whether it works the way that you are coding some program and then you rely on outcomes, or whether there is any process that somehow you validate it.
And so I'll allow, for once, to have a speaker speaking as the last, even though I would always be fair. So now I'll allow you to answer the specific question.
Thank you so much. And my answer will be concluding all this because it's those really, really good question. Because if we have setting that we validate the result according kind of our data sets, our kind of quantile, we can, and even the AI works like that. So it will get a result. And if we get kind of unexpected result, we can say, okay, this is bullshit. We don't need this. But maybe it's the best solution. And so it means we should be really open and really see the answers and be really kind of thinking, okay, maybe this is not so what we expected, but it has certain qualities. And it's about our kind of attitude, what kind of qualities we looking for. And it's always so many parameters. So don't throw out new innovative solution.
Okay, and we're ready for the coffee break. And I just want to give the chance to the two speakers to, you can also give two words last if you have something to add, or
Maybe Ingrid first. Or?
Ingrid?
No, I think be materialist.
Okay.
A new idea.
It's difficult not to be if you use AI, but here, please.
Yes, I hope that we were able all together to demonstrate that AI is kind of the future and that it can be used, although we always need to be careful. But you can find obviously the right balance and address some of the current challenges that we have as architects and as creator of the future world we live in.
So with those remarks on balance and probably having a human future with the use of AI also, I'll let you all go for coffee break. We're supposed to be back, let's say, a couple of minutes past 11, so we have a little bit more time for coffee. And then we'll start the second session of today. Thank you, Ingrid, also online. Thank you to the two of you here present. I will see you all in a little bit.
I'll go for a coffee too. Hello.
Okay, so I think we'll just start now, so we don't get too delayed in the program. So thank you for coming back to my very tight schedule today. So we are ready for the second session of today, which is, again, we're focusing, as I said, the very tangible aspects of AI as a technology, how it can be used in the architectural profession as a concrete tool. And of course, the architectural profession has evolved over time, and the tools that are being used within this sector and field are, of course, developing alongside and also transforming the field. So in this session, we'll go more into the details of the architect's work, the practice of architecture, and the daily use of digital tools for building design. And of course, one of the things is, it's not only the very micro practices of an architect that is changing, it's actually also the entire field, the entire infrastructure, the organization. So we see more smaller architectural businesses now, because we can have more. We don't need all the in-house specialists, but this of course also challenges the different specialized fields within architecture. So these are the kind of topics that we'll talk about today, and I hope that all my speakers for this session has returned from coffee break. So we have, and I would also like to invite my three speakers here that are here in person to the floor. We made a little bit of changes in the program. Unfortunately, we had a replacement of a speaker for later today, so someone is changing. But who we do have here with us at this session is Filippo Lodi, Head of Innovation and Knowledge Management on Studio, that I would like to see here, and Joseph Musil, Architect, Fosters and Partners from the UK, and Pascal Terracol, Architect, DPD, full professor, Doctor in Geography, University Paris, Sorbonne. And let's do it like we did it in the last session, have a round of introductions to the topic that we'll discuss later in the session. And I'll start with having Filippo Lodi, Head of Innovation and Knowledge Management on Studio, to present. Originally, just for the ones that are really looking at the program right now, Matthias Del Campo is still here with us, but he will join the next session. We changed a little bit in the program, but I'm sure that will work still.
Right. Good morning, everyone. I hope you had some good coffee. The one at home had some good coffee at home. Presentation is going to come up in a second.
Hello? Just to make sure that we get the right presentation, because we have a change in. So now we have Filippo Lodi.
Yeah, that's me. That's the pink one. So my name is Filippo, and I'm a director at UN Studio, where I lead a team called UNS Experience. It's a multidisciplinary team. It's an innovation and experience design lab. It's about around 30 people, different backgrounds, computer science, engineers, product designers, urban designers, strategists. All together, we are on a mission to create better experiences for the people and for the planet. That's kind of what we do. We are part of a UN Studio. UN Studio is an architectural practice globally present throughout the world. 8 different offices, Australia, US, Shanghai, Hong Kong, Dubai, so different parts, but headquarters is in Amsterdam, and that's where I'm based. And this is probably one of the most famous projects, which also shows a different take at it. This is a sailor that crosses the bridge every day when he comes back home, and he is so much intrigued by the bridge itself that he had tattooed it on the back of his body. And that is the stories that we create by doing design. They are really story that reflects on how people and their experiences are. Experiences transcend the spaces. The the Mercedes-Benz Museum in Stuttgart, which has been realized in 2006, has a full program of activities, and of course we link that program to architecture, to its aesthetic, to the way it's made, and there is an intrinsic relationship for us to technology, the way we had seen that, the way we kind of basically programmed components of it to have control, to create efficiency. All that is part of the history of how we've been doing design over the last, let's say, 20 years. So this is 2006, so not 20 years ago, but almost, right? So considering we started 2003, yeah, it kind of dates back. And technology kind of, goes forward, right? So there is a lot of things in terms of control that we've been utilizing in the past years. So there's a lot of information modeling. There's a lot of test fit. There is a lot of using data to control. Lately, we've seen more a sort of immersiveness into things, so using technology to translate, so text to image, voice to image, image to voice. There's all sort of kind of mechanism of translation, mechanism of immersing, so you can collaborate digitally through the metaverse with other people. There is real-time imagery, so technology is evolving because the computation power of our machines, the possibility that we have to use technologies is changing. There is new form of seeing, camera visions, technologies get embedded into our reality, and people absorb that. The gentleman over here is called the famous most connected man in the world, right? He uses all sort of gadgets to connect. His toothbrush connects us to his smartphone connects us to his smartwatch. His gym program connects it to his the way he lives. The car connects to the watch, connects to the street. So all of a sudden, technology is much further pervasive, and it's all part of the built environment. So everything we do is part of that. And in the kind of movie scenes that we see now, technology is fantasizing about how robotics will come and take space into our lives. And all this is just simply part of our built environment. And as architects, we design the built environment. We design with all this. Second, we know that urbanization is growing. Cities are much bigger than ever. And there is that lingering question of, what is the metaverse? What is the mesh? What is the future of everything that connects with each other? And as we kind of, as Marshall McLuhan famously said, so we build the tools and the tools are building us. And the difficult thing about that is that we are not, as human beings, we are not trained to think how technology develops. So technology develops much more exponentially. It's very easy to count 30 linear steps, but what are 30 exponential steps? Because technology changes exponentially, and that we cannot do. So then the question is for us as designers, how do we future-proof the future? So maybe linking to the first conversation we had earlier in the morning. So how do we foresee the future changing, and how do we capture that? How can we do that? So I brought with me 3 strategies and 2 stories that tell how we future-proof the future. The strategies are, well, first of all, we need to look into relationship technology. Where is the human and where is the machine? How do we relate with each other in all sort of fields? Human machines are more intriguing than ever, and we are specifically interested as designer in the place in the middle where the 2 things complement each other, where either humans are complemented by the machines, or where the technology is augmenting humans because things that human could not do on their own. But it's very interesting where that happens. The second strategy is to kind of think at a broader systemic effect of the things that we do. So we don't design for human alone, we design for a broader, a broader shared value with each other, and that broader shared value needs to be kind of seen. The third strategy is what is our role as designers, and that's where I'm always fighting every sort of discipline, in the sense that I believe very much to kind of take away the notion of the traditional disciplines and kind of work in an integrated way, in a multidisciplinary way, where that is the way we can create the future. So what are we as architects if not the collage of a lot of different experiences and taking those experiences with us. So two examples of where we apply these strategies and what do we do with it. The first is an urban design, much based on a quadruple helix model, where we try to bring in different entities together to create win-win-win-win situations. It's an urban design in the Netherlands. It's a master plan called Brainpost District, 1,000 homes, of which we are at the moment prototyping 100, and the old master plan has been designed with the notion of embedding technology into it, where the assumption is, could we create a place where every person that lives there does not have to pay rent or mortgage? So everybody that will live here will actually live because the built environment is paying on its own. So technology will help to do that. And what can you do if you don't have to pay rent or mortgage? Well, you can have more time for playing with children, for cultivating your garden, you can work less. And the technology that supports it is a layer technology. There's a lot of intelligence to connect. There's a lot of sort of data topics that we had to develop. We had to bring in. We had to bring in a data ethicist to understand the relationship with data and the ethics of how ownership of data is. So a lot of lessons learned to create this, and at the moment there are 100 homes that are being prototyped in this. So there's a lot of mechanisms to bring in the different use of technology, of materials, of constructions, and the intelligence that these will have once the building are realized, and they will keep on optimizing. They will be used to share information. So the solar panels, you can trade energy with your neighbors if you're on holiday, you're not using it, and that brings in forward. The second example, which is a very small scale, but deals with the relationship of human and technology, the same as the master plan does, in a very large scale. It's much more complex. It's a smaller scale, and it refers to stress. We see the kind of overpopulation of stress being a place. This is what they call the rage room in Moscow, and we created a reset. It's a series of pods that you can go inside, and you're measured brave wavelength and pulsations. This type of information is condensed into what we call the reset index, and every time that you go inside, the AI, the technology, the algorithm learns from the data of you going inside and kind of suggests a different way how you can distress yourself. And that's a product that we created. And so that brings us to the question, so how do we future the future? Well, how do we do that? And how do we put that in practice? Well, we believe much in seeing the fact that kind of the world of technology, society, economy, they're all kind of changing together. And how can the design, what is the design line that connects into it? And what is the architect line in it? And so how can we bring in different a notion for our future? And we believe much in not confining ourselves to the smart, to the convenience, but to use technology to embrace to embrace different questions, and the questions that are more about the nature of value that we can create for the users and the planet that we live in, and to bring that level of notion into our design. Thank you so much.
Thank you, Filippo. So Yes, please, Joseph Musil.
Hello, everyone. Okay, so my name is Joseph. I'm going to be talking about AI for environmental design at Foster & Partners. I work for Foster & Partners in a small R&D group called Specialist Modeling Group. And so this is one of our older buildings in London. It's fairly known, but it was one of the first buildings that was designed in a way that was considering the link between the outdoor airflow and the indoor airflow. So putting window openings in specific locations and seeing when you open them, what happens on the inside to create a healthy environment. Now, to do that, you need to do lots of, you want to do lots of simulations to actually understand, because especially wind flow is a fairly complex phenomenon. So on the left side, you see you're going to start doing analysis of the outside. It's called CFD. And then with combination of tools, you can analyze when you open certain windows, what actually happens on the inside. Now, why would you want to do that? So you can design spaces for certain ranges of wind speeds, and these wind speeds directly have impact on what people are going to enjoy doing there. So you can design spaces for standing, sitting, strolling, walking, or you can make the spaces actually very uncomfortable if you don't design it well. So in this way, you can directly promote healthy lifestyle by, telling people, well, providing spaces where people can go outside and enjoy the time outside. And the same applies to indoor spaces, but unfortunately, the idea of modern building today is not far away from building a submarine in air. So it's tightly sealed. The air is coming from somewhere far away from the building. It goes through meters of pipes. They might be clean or not. And actually, at the same time, you have the fresh air just a few centimeters away from you, just behind the facade. So if you could open it and get it inside, you might provide healthier environment, and also the buildings consume 40% of the world's energy. So if we can work more with the idea of passive solutions like natural ventilation, then we can improve, hopefully, the built environment. Another reason to do that is that humans are not necessarily designed for like a steady environment. Humans were designed to be in a dynamic environment. So if you look at the image on the left, that's a typical picture of a park. You have a little table there. You see there's a high range of colors, high range of temperatures, different areas of different temperatures, a bit of airflow. On the right side is like a typical office space. It's all very neutral. There is this idea that everything has to be constant temperature, constant lighting, but actually is not what humans enjoy. One of the reasons is that it engages the brain in different ways. So dynamic environments engage brain through multiple senses and create a more enjoyable environment. The right side, you can see the thermoneutrality engages very little the brain, and it gets boring and not enjoyable. So now if you look specifically at passive solution for airflow, you might argue, well, it's not always possible to open windows, but if you look at the map, you can see if you allow for some sort of range of temperatures or a range of airflows, most parts of the world will allow you to do the passive solution. In terms of analysis, we have a whole range of tools that are able to help us to design that, and they vary in terms of complexity and time. So the main problem is the more rough estimates you get, the faster it runs, and the more complex simulations you do, the more time it takes, and the most detailed simulation, they can take up to weeks, which is a big problem, because when you design a building and you are in a concept stage where you really focus on massive changes, you can't do, the later in the project, you can't do changes of the overall shape, for example. That's just not unthinkable. So you need to do, at the very beginning, a lot of very fast simulation to allow you to do big design changes. So AI, in this sense, provides an opportunity to do prediction of certain simulations with accurate enough that's useful for the design stage, but run almost in real time. So this is one example of how we used, so we built in-house a little AI model that predicts the airflow. This is, for example, a master plan for a tropical island. And the idea here is to play with the buildings in a way that you provide just enough airflow in between the buildings to support the idea of cooling. So it's not too much, so it's not comfortable, but it's enough so you have a bit of a breeze and it feels good. Another example, this is the opposite, when there is too much airflow on the outside. So this is in Shanghai, particularly in Shanghai. And we wanted to design the blocks in a way that they are open. We don't want to create like a solid wall to stop the wind coming in, but we want to protect the inside courtyard. So it's a healthy place, you know, to be there. You can go for the run, picnic. So you have just the right amount of airflow coming through. Another visualization, the interesting things we can generate, we can predict data in a format that we can plug directly into engineering software with the AI, because it's up to us to decide how what sort of data we predict. And it allows us to use standardized tools to visualize that, help us to communicate the design. So now what we have is this traditional workflow is you have a simulation, you get a report, you influence the design. The problem is, as I said before, it might take anywhere up to 1 to 3 weeks, which is just too slow for concept stage. And the second big problem is, even if you have the best report in the world, typically it doesn't tell you how to influence the design. It tells you this doesn't work or this does work, but it's up to the human to use the report in a meaningful way to actually make changes to design to improve it. So we're proposing, can we use AI to help us with both? So it's something I call forward direction. I already showed you we build a model that can predict the simulation in almost near real time. But then we also look at, can we actually reverse? Because AI allows us to make unusual connections. So can we train it in the reverse direction? Can we start with the simulation and ask AI to predict the buildings, where to put them to achieve such a simulation? So this is a graphic representation of a circular workflow. On the top row, you see this is the forward direction. You take a few buildings, and you use AI to predict the simulation. And then you manipulate the simulation directly, and you ask AI to predict where to put the buildings. The good thing is, with all these parametric models we have today, we can easily generate whatever training set we need. And you end up with a nice circular workflow where the architect works directly on both, on the design of the building, but also on the effects of the building. And you use, in a circular way, the AI to influence both aspects. And this is our, so we implemented it in typical architect's tool, Rhino Grasshopper. So it's fully interactive. You can build your models and see in real-time simulation. The interesting bit about if you have simulations or anything that suddenly runs in real time, and you spend some time with it, it gives you a little bit of intuition how the design changes influence the analysis, for example, and gives you a bit of better understanding of your design. It's all run in 3D. That's important because obviously, for example, the wind flow is a 3-dimensional problem. And this is the moment when you go into the reverse direction. So you put a threshold on the wind analysis because it's not meaningful to directly manipulate CFD analysis. But what you can do is you can say these red areas, these are the zones, let's say under certain speed that are suitable for running or park. And what you want to do, you want to design these spaces directly. So you start manipulating it and you ask, yeah, where do I put buildings to achieve such effect? And then because you can directly go straight into the other direction, evaluate if the simulation is doing what you are asking for. In the future, the interesting bit of AI, when you open the box, you can start incorporating your custom functions like physics-based function to make it much more precise. We would like to implement it in some sort of Gantt style, so the analysis gives us different solutions to the design. But really the bigger picture here is, can we spend less time designing buildings, and can we spend more time designing the effects of the buildings they have on people? Because that's how people really perceive buildings. It's through the light levels, it's through the temperatures, it's through the airflow, sunlight, etc. And hopefully AI will allow us to make buildings more performing better, but also healthier and happier places.
Thank you. And so we have the last speaker for now, and then we'll have the debate. Pascal Terrecol.
Hello, all of you. Thank you for the invitation. A few words about my background. I'm coming from a software developer, and I've been an actor for putting on the market of one of the first 3D synthesis model in the late 80s. And now I am in charge of a master of a master which is based on we are operating a chair architecture and intelligence in Paris, in fact, and we have already trained, let's say, something like 50 students on a prospective way on a subject from 2017, in fact. So, what I would like to present you is the question was, what about the deal between the tools which are pricing with AI and architecture professional? And it's not so easy because professionals have a side of those tools, and there is a disruption, a kind of disruption of those tools, in fact. But we are on the go, and let's say, we have to displace a kind of automorphism of the architect, and we have to train them. And we're going to go to open a professional master on that tools. And we invite ACA and maybe other actors to join us in Paris for that subject, because it's a real goal, in fact, to provide the knowledge of those tools to the professional of specialization who are the architect, in fact. So this is a real invitation, and maybe you and Studio and maybe Foster, you are well, we can work together. That's it. Let's say, what is the value of architect? So it is a real subject, because the question is evolve, and we cannot let this space open to only, let's say, economics actors or marketing actors, in fact. And they are not so far from that, and we are working to open this kind of tools to the architecture fields, in fact. That's it. And a big question, is we have in French something like DTU, which has sheets, technical sheets, in fact, to regulate the way to construct and to design a building. And maybe this material could be fit in neural networks to provide a graphic action made by architects, and to make alerts from them. And this is maybe in a prospective way we are waiting for these kinds of tools. And it is a real situation, and it is we are dreaming of these tools. And I think we're not so far, because we have CSTB in France, and they are managing this material, and it's a big question, in fact. So we are in the situation in the last months. We have the fact is several tools are pricing, and let's say we have speech to text, which are already online, and we have let's say, I made for myself. I've published my course, which is a analytic geometry course, because the parametric modeling tools are already here, and it is impossible to let the students outside this field, in fact. And now, with a simple prompt, I made a survey of my students on the question: do they know parametric? Do they know what is a ruled surface? What is HP? A hyperbolic surface, and so on. And I made not so far the same question to the tools which are here with a prompted rule. And for the situation is, for now, that students are better than the neural networks. But it is the situation is going to evaluate, because neural networks are learning too, and we are providing the knowledge to them. So. And let's say there are several tools. It is really, there was a few weeks ago, these tools were not there, and we are in a prospective way dealing with this situation with our students. And text-to-image exists. So the constat is Daily, for example, knows about Le Corbusier. So it's a constat, in fact. and DALI, for example, but maybe also Stable Diffusion and so on, knows about modern architecture. This is an example. And the very last announced tools which has been raised is we were speaking with our student about we're not going so fast to wait for, let's say, a text-to-model tools, and NVIDIA has provided, in fact. And with a simple prompt, you have a mesh, and this is incredible. In fact, it has to be tested, but it has been invited. And the question is, if we can write something to design an architectural feature. Let's say those aesthetic is going to be disrupted by semantic. And this is a big question because in the stakeholders, the architects are very well fitted with the vocabulary of semantics because they know about architectonics. And let's say other stakeholder, maybe engineer doesn't know as well this kind of feature, in fact. And the question is, does, let's say, the question is, do we have to design something, or do we have to write or to enhance a project now? This is a feature, in fact. And this is an example. The row shows the Opera of Sydney. So we have to test that, but this is announced. And so the semantic is a very big tool to get hands on this AI tool, in fact. So, for instance, we are working. Let's see, we have. I'm directing three theses, and we are in a disposal, which is a French one, which is a contrat cifre, which is a triangle between academics, industrial, and university. And we have one of our students, which is this company, which is a society, Association accusée pour la qualité de la construction. And they have, let's say, something like 25,000 data sheets on sinistrality, in fact. And this material can provide fitted in a, we'll see what is going to be the result of the thesis. But this data material, is a really specific one to enhance the knowledge by sinistrality and to provide something like prediction of what is going to be suitable to design something or not, in fact. So, and we have also we have built also a lab which is data driven to make urban analysis, and this is done by open library and open tools, in fact. And it is already working, and we are training our students on that tools, on that process. And the question is, here we are on Paris with data.fr, which is an open data provided by the city. And the question is, what is the capability to enhance the height of the building? Yes, okay, I finished. So this is a survey of the three theses. We have one, this is accusé, the first one. The second is based on the air park and the way to build, let's say, Ashtoll, VTOL and Ashtoll, which is a situation to make links between hyperdensity and rural, in fact. I understand. I just present these three views, and this is a question about les nouvelles mobilités aériennes with avion Mauboussin, and the question is how to provide a service near upper density, and this is a question of air park, exactly. I think it is the end of my presentation. So the fact is, urban analyses are already on the go. We are going to open a professional master, and we're going to enhance the knowledge on a prospective way on that subject. Thank you.
Thank you. So we've had a really presentations of a wealth of different ways of using AI very concretely in the architect's work, and also some academic reflections, and interesting to see also how students can be involved in this. So I was thinking that what I think would be the most interesting thing to try to do throughout these sessions is to start off by asking you about the opportunities of AI. So starting with the more positive note, understanding, so what do you see if you have to gather, with all your wealth of knowledge and all the practical applications you've been presenting, what do you see as the biggest opportunities of AI right now for the architectural sector and profession? Let's start from...
Thank you. The opportunity is pedagogy and research, and we are on that track. I answered the opportunities. Our goal is pedagogy, research, and to train professionals on that open state and landscape of tools. In fact, that's it.
Yes.
The opportunity that we see is that technology can enable us to create better lives, right? So we can design spaces where people have more time to do other things, because technology is taking care of some of our some other aspects of what we couldn't do before. So how can we enhance the quality of life and the quality of the environment that we design for?
Yeah, similar like what I presented. I think the opportunity is to design directly for things that are traditional as a result of our architecture. Like the thing, how you perceive buildings is sort of like, it's a result of a design process, but you don't design necessarily that. So we can flip that. We can really look at how people feel in the buildings, which is generally so complex to even start analyzing. But maybe with the computational tools and AI, we can actually directly manipulate these things. And I think also generally, like, we have this, like, every year we get a new computer in the office, which is much powerful. And we always hope we're going to get things done fast and we're going to go home sooner. But what we end up doing, we just end up doing more work because we realize we thought we only wanted to have 3 options, but the reason we did only 3 options was that we couldn't do more of them. So the opportunity is to incorporate much more data that is related to the users of the buildings, which we didn't think we could before. Yeah.
So I mean, listening to all of you, what I see kind of on the top of it as something that is seems to be really helpful in the architectural sector is this idea of making sense of a lot of complexity. So complex environments, complex spaces, and also making processes more efficient. But at the same time, I think that, I mean, when I look at this room, for example, it's a wealth of complex, not only information, but human factors and human being in environment. There's air, there's faces, there's memories, there's cultures. Is there, and now I'm moving from the opportunities, is there like, how do we ensure, and we talked about balances earlier, how do we ensure that these very good ways of standardizing the architectural profession and the methods that you're using, how do we make a healthy balance in this?
I would say we're hopefully not going to standardize anymore. We're going to be more accustomed to, all the people inside. So it's going to be more dynamic environments, more customizable, because I'm sure today design are biased towards certain group of people anyway, and that's the standards are. So hopefully we're going to go away from standardization and go more for customization.
Can I add something to my question? Because then, I mean, an AI system, an AI tool is very much designing right now for the mainstream. That's what I hear from my profession, working with the ethics of AI and also data ethics. What is happening is very much a design for the mainstream, the standard. And so in many of these kind of cases, when we're thinking about we're designing for people, and cultures, we might reduce it to a mainstream. So I'll let someone else answer also, but I can see you would really like to answer that question also. So.
Yeah, if I can add something to the topic. So if we see it, sort of technology in a positive way, in a sense where it allows us to do things that we couldn't do before, the biggest threat to it is our own knowledge of that technology. So we need to create more literacy of the technology itself, of what is under the hood of the technology, to kind of be sort of aware of the biases, be aware of the ethics, be aware of that. So in fact, what we are doing today, by just talking about it, it is actually the right thing to do, because we need to kind of know more. So we need more masters in data literacy for all the architects, so to enable us to kind of to use that as a tool, and to do not make sure that that tool makes us again, and that is the scary part. So if we can, and then that's the only way we can create a sort of a balance.
I agree with that, Philippe. Architects are in an open epistemology scheme, in fact, and it is a real quality. And I think that sinistrated data, as I mentioned, has to be fitted in a BIM object, in fact. And this is a real situation and a real service to be provided to the architect and to the society as well.
So that is, I mean, very concrete ideas on you know how we can actually incorporate these more ethical, maybe social considerations. And then if we think about one thing also that is general, and this is not only for the architectural sector, this is this idea of AI and the implications for the workforce in specific sectors. How do you see this? And also based on your experience from working in the field for many years, do you see any challenges, any opportunities that are, you know, in terms of the workforce and the employment in the field?
There is a real challenge between the gap and the deal between technology, data, and public space. And this is quite a politics subject, in fact. And in an open mind and with an open tools situation, in fact. And we are getting with nos élus en français, je ne sais pas comment on dit en anglais, our policies are major, in fact, and in little town, and this is a good way to enhance the quality of designing public space and so on.
I got my own one now.
I was going to say I think we need to involve new professions in architectural offices. I think we need to, at the moment there's a bit of an issue to get enough interest of the highly intelligent people in other domains, which architecture is not necessarily seen as the dream field. So I think we need to reach out to those domains and, you know, show them that we have super interesting, super important problems to solve. So we attract the new, sociology, computer science. Computer science is probably quite common today, but let's say AI, you know, the most intelligent students, they don't necessarily see architecture as the dream where they want to go. So I think we need to change that. And I'm sure we have, it's just they not are aware that we have super interesting and important problems to solve.
The opportunity there is to reflect on the profession of the architect in itself. So who's an architect? And well, that might not be the same architect as Le Corbusier was. That's the future of the profession is not the same. Although we still design, but there is an opportunity to take in different disciplines, such as so the kind of computer science, the technology, the sociology. So we can bring in different expertise to the value of this profession, which is mostly a sort of a generalist. The architect traditionally is somebody that coordinates all all different things. So how can we rethink the profession to make it more valuable and therefore then attract the right talent? How can we reposition this in the field of the things that we do? Can we make it relevant for it? Otherwise, then we don't attract the right talent, the right people, and the quality of our built environment decreases. Right? There's all sort of there's a down spiral to it if we don't do the right job as professionals ourselves.
I can add something. There is an item which is really important, it is nature. And we are working also in the process of recycling material and so on. And this is a real goal to values, let's say, environmental and sanitary aspect for society. So, and we have the tools to do that and to go on that track.
So let me open to the floor and see if there's any burning. I see a few hand, one there and one there. So I think you were first, the gentleman here.
Thank you very much for the amazing presentations. I really enjoyed them very, very much. I have a couple of comments or questions for you regarding maybe a common language understanding of how to talk about AI and architecture. Maybe we can, I hope we can agree that one of the major paradigmatic shifts that are happening right now is a change from expert systems to learning systems. And considering that, it means that we're moving away from something of a top-down, let's say, parametric modeling method, which basically specifies what you want to have as a result and rather interrogate large data sets to understand problems that we want to solve in one way or the other. Now, in the presentations we saw, the vast majority was actually parametric modeling that we saw here. And I have to admit that I have a hard time with a presentation that says AI does this, AI does that, without giving details like which algorithm was used, which data set was used, because those are the things that inform us as a community more than just saying that the AI did this or that. The other thing I want to comment is that AI is just an umbrella term, right? I mean, it's something that covers a vast area of different machine learning methods, algorithms, et cetera, and I would appreciate more specificity with this sort of information.
So that's a very good question regarding getting more, into the details of, and probably also will be practical in terms of when you're sitting as an architect, what kind of tools, which kind of services are you using, and then what kind of models. So I see you. You seem very ready to answer.
Yeah, I can reply to that. I think there is in what I was referring with sort of the literacy of the technology. That's really where the notion stands behind how we communicate the things that we communicate. So often there is a lot of lack of knowledge of the technology that is behind the things that we show, and that literacy is very it's required to have a discussion of that level, as if we would talk about the sort of data lake that we're using to get information cross platforms, where the smart city project that we're using, how did we build the data platform on it, which a cloud provider we're using, what is the choice of the cloud provider. So there is a lot of knowledge behind that, and that's really the one that we should have time to dig into and really talk about. And in order to equalize the conversations about it, then we need to bring more specificity to the wider audience of the architectural industry to just even have a conversation.
First, there is also two subjects. First, there is the Digital Act, which is on the go, in fact. So you have to be aware of that. And also, there is these tools are not on the go, but they are not so far. I think, in a simple gesture, a graphic gesture done by an architect within a software, we would like to have an alert saying, "Beware, you're getting out the juridic or technical specification, in fact." And this has to be done, in fact. And the assumption of this assertion is to have a good quality of reuse, recycling, the respect of the regulation and the impact with environment too as well. So this is a prospective site.
I would just agree. I would actually be against ourselves if we don't talk clearly about what we're doing, because it hides the opportunities and creates some misunderstanding. So we should be more clear about that. I want to make my note on the difference with the learning algorithms. I think that's going to be something that probably designers will need to get used to, because the tools presented, we keep thinking that's going to be something that keeps learning as the office evolves, which is something completely new in design. You're used to that. You have a tool, and half a year later, it's going to do exactly the same thing. But with these tools, there's a good chance, half a year later, they're going to be giving different results. So I think something we need to get used to. I don't know what the implication is going to be, but I know it's going to be something. You're going to lose a bit of the guarantee what it does. It's going to be more opportunities, and we need to find ways to work with that.
Yeah, it's very important in general to understand the granularity of the use of AI, because if we want the AI to be empowering, then we also have to understand, the tools that they're first of all, they're not available to all, and they're very different forms, and they're definitely not neutral tools, all of them. And then there's the literacies involved in this, so that's a very important point. There was a question here.
Yes, thank you. I have a question to Filippo Lodi. You brought a slide that was one of the more interesting ones today. It was 3 columns. They had humans on the left side, then machine, and then in the middle the merger between humans and machine. Unfortunately, it was too quick. So could you maybe make a recap on it? Because I think it gives us what are the potential of the humans, what are the potential of the machines, and then what is the potential of merging it, what we are talking about.
So the perspective comes from the fact that on one end, we know what we can do as human in terms of the process that we have in decision making, in designing, in collaborating, and we know what the machines can do, which is the parametric component. You give something the machine does, but you have no interaction with that unless, well, of course, you program that or somebody has programmed that, so that stands alone. And the effective intelligence for us is when we can create an interaction between that. So either by having the machine support us in doing things that we don't need to actually do, and kind of optimize, speed us up in the way, or really create sort of an augmentation of the things that we could possibly not do, because we cannot think exponentially. We cannot have in seconds result from Watson, right? We are not Watson, so we cannot. We can augment what we do, the decision that we take as a human being, because of that. And if we work very hard on that intersection where the two things are there together, I think that's where we can create a far more interesting result.
Yeah, and then the interesting question for me is, on the human side, you had the verb judge. So humans are good in judging. We all agree, right? Preparing this conference, we were joking about, would it be possible you have an architectural competition, you have judges, and you have one AI judge? What do you think would have to happen that AI judges would be possible? Or did you ever work on this?
Yeah, I think that's a tricky question, but it would, if I, thinking out loud is reflecting on what the first speaker of today talked about. If the data that is used to judge is trained on the past, then how can we judge things of the future? That would be the main question to do that. And so far, that's the difficult relationship yet to create. So from our stand, so far, the far more interesting one is if we combine the human and machine, then we can create something. We can look at the future in a different way. by kind of speculating on things that do not exist, right? And by not just looking at the sort of data set, which is somehow an existence of the past, but if you could use it to kind of generate things on which they don't exist. And there are all sort of loop there, but they're also always starting from an existing data set, which is the conundrum of the whole assumption so far.
I would like to recall about your question on human. The three major paradigms of AI, which are classification, regression, and human supervision. And the last one is maybe the most important, because all we are listening, we are training the neural networks, in fact. And maybe maybe it's we don't realize this kind of things, but already with Google and so on, and with the tools we have on other subjects, but fitted in the architecture fields, there is a global knowledge which is uprising, and it is the society and human components from this way is a really important one.
So I can add two kind of interesting, I don't know if you could call it facts to this. Actually, someone did make an AI judge for a competition. There's a very famous case of an AI judge for a beauty contest. And it turned out, of course, when this, people had to send in from all over the world pictures, and this AI judge was then applied. Of course, it was just a piece of software. It wasn't really a robot or anything. Was to decide which face was the most kind of objectively most humanly beautiful one. And then when it came out, it turned out, of course, that it was incredibly biased. It only chose white faces, and wonder why. It was because it was mostly trained by pictures of white people. So in that sense, you can see that an AI judge, I think the learning thing from this is that an AI judge to judge something so humanly kind of unique and characteristic would only be able to reproduce what humans already can do. Another part that I find really important to frame this debate is the kind of the geopolitics and the regulations that are being created around AI at the moment. There is the idea that the EU is creating a kind of human-centric approach to AI in terms of governance. So there's a lot of regulations and also the AI Act that has this focus on creating governance structures and also use of data and creating data systems that are and AI systems that have this component of having the human and it's not very like the human in the loop, but the human in command. So via different both technical but also social and organizational aspects. So that's a really important point to kind of make,
can I just add one?
saying that we're in Brussels right now.
It's interesting to think that I don't think just having a human in it doesn't necessarily mean it's not biased, doesn't it?
No, and just to that we have an AI neither. So we have to find some combination that in some way will ensure that, not ensure because everything is biased, even an AI system is biased in the way that it always believes that the system is complete.
Maybe in a way the AI might help us to understand that what we think is unbiased is actually biased by showing that, if you try to repeat the result, it's going to tend to have some bias. I don't know.
Could be.
I would like to add something. We spoke about human supervision, but we can add software supervision. With a simple line of code with Pythons, you can put a server not so far from a denial of services. And as I mentioned, from text, the link between text, semantics, aesthetic, and maybe ethics, we have to be aware with this kind of thing, because with a simple lines, the power of a processor and maybe a few processors, you can influence the data knowledge and maybe put aesthetics outside and to disturb it, and maybe ethics. And this is a political subject, in fact. Also.
Yes, and technological and social. I was wondering if there's any questions from our online participants here. No? there's no questions. Well, so we have any questions from the floor? No. So let's, we have a few minutes left, and I'm wondering, so how do, AI architects or the architects that are using AI, so how do, on general terms, or not only architects in general, not only architects using AI or professionals working with AI, how is this perceived in the field in general, the uptake of AI technologies?
Not so easy. There is, let's say, in France, we're coming from Beaux-Arts, mood and so on. And this subject, we are a few schools in France to train our students, but we are on the go and we are working on so we are on a paradigm of displacement of pedagogic models, in fact. So.
Well, I can see there is a direct relationship between the level of understanding of it and the level of excitement about it. So I think the more you understand it, the more you get excited. That's what's happening, at least in our office. So there's lots of interest, and there is a bit of a fear, but it tends to realize that's people who don't actually no idea how that works. So I think it needs to be more literacy and just, it's a tool. There is a potential risk. We should keep it in mind, but not to be clear about that.
But okay, come on, Philippe.
It's also, if we refer about AI, on one end is the sort of the technology that we use as a part of the process that the architect does to do the architecture, and on the other hand is the technology embedded in the spaces or in the built environment that we live in. So it's two different worlds. One is more what some architects might be really super energized by the topic, and they have passion about it, but they would require more knowledge to do it. And on the other hand is sort of the application of this field that as designer we can apply to the built environment to really capture a different results, right? If we embed a full city with sensors and we can get informations of all sort of things that are connecting to us, then it's less about us designing, using that as a design tool, as a process for us as professionals, but it's rather what are the implications of that technology in the places that we design because that technology is inserted into it. And the second one, I find that far more interesting than the first one.
Can I ask quickly, and maybe also you can answer that question. Okay. So if you're an architect, and this is the very last question because then we are off to lunch. If you're an architect that really would like to use some of these opportunities, very concretely advice, what would be your advice, people that are really working with this and using the opportunities?
Invite professional in our session in our master. We were yesterday with the French Ministry of Culture in a seminary based on the chair. And this is a question, the loop between pedagogic skills, research, and practical. And so the professional is really important. And we are going to open this kind of training to the professional we are invited. Maybe at Europe scale, welcome.
So attend open courses that can help you. So that's a very good advice. Filippo?
Start a startup or do something in it that requires that technology to be bringing it forward in a different way. So kind of be a bit more radical into it.
Yeah, it's like to start learning about it. There's so much for free today online that you can just start being like learning these courses online and reach out to specialists, learn about it really.
Okay, so those are all good advice, and then I would also suggest that if you want to embark on using AI, of course there's also the sites that we've been the components of being aware of the social impacts and the ethical impacts and these things. So there's actually a very good guideline for using AI in your work. It's called the ALT-I guideline, one that the high-level group for on AI, the EU high-level group created, that we created. An assessment list with questions you can ask yourself when you're using AI to see if you're keeping an eye on also this human relation. So I just want to say thank you to the three of you. Amazing presentations, very interesting conversation, and now we're ready for lunch. We will be back at 13:30, and the lunch break is where? Just outside the room. So please, thank you. Thank you.
Thank you.
Okay, so we're getting ready for the second half of the day, moving from the tangible characteristics of AI as a tool, moving into these more kind of, we could say, discussions about the existential challenges, we might call it that, and the legal and the ethical aspects. And we are so lucky that we have a keynote speaker to introduce the second half of the day, just like we had one in the first half of the day. So of course, I mean, one way to talk about this is, as we've been talking about throughout the day, is this relation between humans and machines that AI represents. So there's the imagination about, you know, the reproduction of the human mind and human qualities. And so, of course, this is a technology and a development that is really invested with many of our own ideas about what role technologies in general can play in our human lives and societies. So one thing we'll be tackling now, and that I know our keynote speaker will be talking about also, is the idea of AI agency and creativity. So we've heard a few times today about DALL-E 2, this new AI system that can create these realistic images or pieces of art from the description of natural language. So you type in something and something artistic comes out, and of course it looks like art and it feels like art, but can we actually say it's a product of creativity, maybe in combination between the human that types in the information and the AI system? But then what is art if it's not an expression of human memory, our desires, imagination, our culture, our politics, our critical reflections? And so this keynote for the afternoon is Daniel Bolojan. He's from the founder of the Non-Standard Studio. It's a research studio. I love the name, by the way. Senior architect and computational design specialist at Coop Himmelblau. He's also an assistant professor of AI, and that sounds like there was more sound. I hope you could hear me before. And a PhD candidate at Die angewandte Kunst in Vienna. And then generally he's a leading voice in the implementation of AI strategies in architecture and the architectural design process. So really looking forward to hear this. And let me hear if we have Daniel Bolojan. Daniel, are you with us? And we just need to see you also.
Hi everyone, can you see me?
Yes, we can. Thank you.
Perfect. Are you able to see my screen?
Yes, we can see you and your screen.
Perfect. All right. Thank you. This is, I think, a very extremely timely, in a way, conversation. So I'm very thankful for the invitation. And I thank you for allowing me to present some of my research that I've been doing on this aspect of creative AI since 2017. So mostly in my research, I have two main strains of research or themes that are recurring all the time. This kind of idea of the concept of encoding intelligence and articulation of design process, in which design intentions or architectural intentions are embedded within emergent processes. And the other recurring theme is the creative AI theme, which explores the potential of teaching machines to interpret, to perceive, and to be creative. Now, when it comes to this kind of networks, with the advent of this kind of new, very powerful AI models, such as domain-specific and task-specific generative adversarial networks like StyleGAN, CycleGAN, context encoders, or more general domain and task-specific like diffusion models like DALL-E 2, Midjourney, Stability AI, and so on, or other large language models, and many other models that are right now out there, AI-driven processes have the potential to disrupt many creative industries. So there are certain questions then for us. Can AI-driven processes augment creative agency? Can AI be used to expand the design space beyond designers' accepted boundary? And to address these kind of questions, I will try to provide a base for what I mean through creative AI, creativity and design, and so on. And for that, I will start to look this kind of, or to address this kind of questions by referencing some of John Giro's work, in which he tries to create a distinction between the view that creativity resides solely in the artifact and it's assessed by society, and the view that some processes have the capacity to generate artifacts that are deemed creative. So how do we determine if something is novel? According to Alan Garnett, his idea of creative curve, if something is too novel for us, we cannot appreciate it. If it's too unexpected and too unrelatable, we cannot appreciate it. And if it's too similar to what we already know, we cannot appreciate it either. However, there is this sweet spot where ideas that we appreciate as creative have a blend of familiarity and novelty. And in the end, all ideas, they reach a point of overexposure where they become cliché and they start lose popularity and downfall until they grow out of date. Probably you are familiar with this example from AlphaGo. So after his loss to AlphaGo, Lee Sedol made a now very famous remark where he was saying something that what surprised me the most was that AlphaGo showed us that moves that humans may have thought are creative were actually conventional. And we are frequently unaware that we are trapped into design local minima. Yeah? Without a doubt, the aspect of human agent plays a very important role in the process. But what we consider to be creative is very often very conventional. As articulated by Derrida, we have a constructive way of perceiving the world around us, which limits our ability to evaluate new ideas. Because everything we hear, see, or read makes sense for us in the context of what we already know. People evaluate these outputs based on what they already know and are familiar with, and when confronted with what they are unfamiliar with, they may believe that those things are new, but what is new is brand new for someone, but maybe not for others. In the end, then, can AI augment and help us expand our design space beyond our accepted boundaries? How do we know if we are stuck into a local minima or if we are operating into a global maxima in terms of design? So as my research explores the potential of teaching machines to interpret, to perceive, to be creative, I'm more intrigued by John Giro's second view, where he's stating that certain processes have the potential to produce artifacts which may be evaluated as creative. Although understanding how social evaluation of an artifact determines whether or not it's creative might aid in the creation of process that produces creative outcomes. So it's important that at this point to distinguish between what we call human creativity and what we call machine creativity, which are two very different things and should not be confused in a way. According to Margaret Bowden, which is a leading cognitive scientist on this topic of creativity, human creativity can be defined as combinatorial, exploratory, and transformational. When it comes to combinatorial creativity, it produces unfamiliar combinations of familiar ideas. Exploratory creativity rests on some culturally accepted styles of thinking or conceptual space. In exploratory creativity, the person moves through this kind of space, exploring it to find out what is there, almost like to try to discover the potential or the limits of that space in question. With regards to transformational creativity, the space or style itself is transformed by altering or dropping one or more of its defining dimensions. So in this way, idea can now be generated that simply could not have been generated before that specific change. Demis Hassabis, who's the creator of DeepMind, also creator of AlphaGo that won against Lee Sedol, and also Deep Blue that won against Gary Gasparov, identifies three types of machine creativity: interpolative, extrapolative, and inventive. So neural networks are very good at interpolation because they are these massive statistical machines that are very good at averaging and detecting patterns in data. And as designers, we frequently engage in this kind of interpolative mode of creativity, where mostly we are combining different idea, different concepts in a way. Neural networks, though, they are not that good at extrapolation. There are very few networks that are capable to extrapolate because extrapolative creativity, in a way, it's a higher level, let's say, of machine creativity, where the machine should be able to generate new samples that are outside of the domain described by the data set. Of course, when we talk about machine creativity, there are many missing aspects, such as machines are not able to understand yet concepts, abstractions or abstract thinking, analogies over memory systems, imagination, and so on. So there are still few limitations in a way that machines have. So although AI can exhibit a form of intelligence and a form of creativity, it should not be equated with human creativity or intelligence. Very often we are stuck also on these kind of questions like, is it possible for a machine to see the same way that the human does? Or is a machine able to be creative as a human is? And I think that's rather irrelevant in a way question, because based on what Alan Turing was also saying, or paraphrasing him, he was asking this question of, can a machine perform something that can be described as seeing, but is very different from how humans see? Because in the end, we don't want to penalize the machine for its inability to shine in beauty competitions, nor do we want to penalize a man for losing a race against an aeroplane. Yeah. One of the most significant shifts when we are witnessing today is this shift from the idea of an expert system to learning system. Learning systems, sometimes we also call them software 2.0. This is evident in computer science, architecture, and many other fields. So looking further in this kind of idea of processes that can generate artifacts that are deemed creative, it's important then to look also at this aspect of what kind of models we have that are simulating intelligence or creativity. And here, just a very brief example. On the left, we have logical mathematical models, and on the right, we have the unorganized machines, which are basically neural networks, which we can describe them as learning systems as well. So these were models that were developed based on the way that the brain works, at least based on their understanding that they had in the 1940s. So expert systems are knowledge systems and are based on logics which features hard-coded in a way solutions, and they require a human expert to input information into the knowledge base. Learning systems, on the other hand, which are based on neural networks, don't rely on hard-coded solutions, but they learn by examples. They learn solutions from first principle. So here, when it comes to architecture, we might consider this kind of tools that we are engaging in with today, like Maya, Rhino, or other BIM kind of modeling tools. They're pretty much expert systems. Expert systems are unable to generalize due to these differences, and they are limited to pre-programmed in a way solutions, making them unable to have solutions to unforeseen conditions. Therefore, they are very great, very good when we use some, or we try to solve some sequential problems with finite steps. On the other hand, learning systems can generalize and offer solutions to new conditions. They are most effective when you want to find insights that you might not even know about. So generalization is a prerequisite then for new solutions to be proposed to unforeseen scenarios. In one of his papers, John Giro talks about how humans seem to be capable of abstracting features from similar experiences and structuring this into frameworks of more conceptual or general concepts. Human beings generalize over even a simple experience. The stronger their experience, the better humans learn. In design, then generalizations are made after each experience and concepts are formulated or formed and altered to suit. When faced with a design problem, for example, the concepts are brought to bear. For example, in transporting heavy objects, finding that the use of logs under a load makes it easier to move the load may lead to generalizations that provide rotating elements, for example, wheels, under an object, making it easier to move. So this generalization may lead to design to the design of objects such as shopping carts or suitcase or other kind of objects with wheels. Now, this is rather important, this aspect of generalization, because instead of using neural networks and reducing them to just simple generators of artifacts that we might consider novel, the networks must be able to generalize in order to generate novel solutions to new design problems. And I think this is quite crucial, especially when we talk about architecture. I think if we were to discuss about AI in arts, probably it's a different kind of level of discussion. But when it comes to architecture, we are always looking at networks, AIs that are able to give us novel solutions to certain design problems. So network, for me, a network that does not generalize is no different from a blender, where you simply just spin things up. And it might be that the result is something interesting that I find creative, but there is no, in a way, intelligence, in a way, in that process. As pointed out by Henry Poincaré, science is built up of facts, as a house is built of stone. But an accumulation of facts is no more a science than a heap of stones is a house. So further than abstraction may lead to generalization that reducing friction between the two elements makes it even easier to move one element over the other. So this is a similar generalization that probably is happening also when it comes to this aspect of Hyperloop. So you see a simple, in a way, idea of introducing logs that leads then to a generalization that leads to this kind of novel ideas. So the next phase here, I'm going to look at certain challenges that this kind of networks have, because although they are impressive and the results are amazing, they are still quite limited. So one of the challenges that these AI models have is that they are domain-specific systems. And when they are used in architectural design as discrete systems to address multiple architectural systems or tasks, they tend to flatten relationships between architectural systems. And this is rather problematic because the outcome of architecture process is codependent on multiple interrelated systems. And in the end, we want this kind of AI models to be aware of the variety of co-relationships that exist between various architectural systems. So these models, they can perform impressive feats, such as image and language synthesis or domain transfers. They can engage in conversations with humans that are perceived as being very convincing, credible. However, just because they can do all these things doesn't mean that they understand what they are doing. For example, an AI model might be able to generate a realistic image of a building, but it doesn't know that the image is an image of a building, or even more importantly, what the building is. And similarly, an AI model might be able to give accurate prediction, but it doesn't know or doesn't understand why the prediction is accurate. And according to Yann LeCun, who's the creator of CNNs, which are convolutional neural networks, current neural networks are like a mirror. They are able to mirror the content of the data set, but they are shallow in understanding. The depth of understanding is as deep as the mirror thickness. In other words, current AI models, they lack true understanding. So if we consider diffusion models such as Midjourney or DALL-E, which became very popular this summer, the workflow is as follows. A user inputs a prompt, and using a clip network, which efficiently learns visual concepts from natural language supervision, we can direct a diffusion model to generate an image based on that input text. So for me, always the question was, does this clip network interpret our images similar way that we do? So this question, then I was very interested, and I was quite curious and started to look whether the network has certain strong biases or preferences. So the way we can test this, we can create a continuous loop of input outputs and observe some of the biases of the network. In this instance, it's clear that Midjourney model has a strong preference towards artists than architects. So in this case, I started simply with some examples from Zaha Hadid and Paul Rudolph. In the end, the clip network is able to recognize most of it as Zaha Hadid, not Paul Rudolph. And then once you start to loop, this process, generate an image, have the clip interpreter read that image and create a description, you see that the interpretation starts to steer towards art in a way. And this is mostly because most of these networks are trained mostly for arts more than architecture. The same in a way curiosity is also, are the networks at least then able to identify the semantic features that are described in an image and also in the prompt. So here, by using certain attention models and maps, as you can see, where you have curvilinear column, you have the AI in a way kind of identifying correctly certain patterns that exist in that image. But AI models cannot count, yeah? For example, they don't know that the hand has 5 fingers. And this is because it lacks concepts of numbers and mathematics. AI models, for example, work with or work by discovering patterns in images, and patterns are repetitive. So they identify a pattern like finger, no finger, finger, no finger, and simply follows, you know, that kind of pattern. But these kind of models, they make a lot of mistakes, yeah? It's just that we humans are particularly wired to notice certain details, yeah? Like this aspect of fingers, a hand is very easy for us to see if a hand has 5 fingers or not, because our brains have this kind of special circuits that identify shapes, faces, and hands and so on, yeah? But all other mistakes they make, we might just overlook them because we don't have this kind of special understanding or circuits in our brain to notice those errors, those mistakes. And the more complex and unfamiliar the results are, the harder it is for us to notice those mistakes. So in this example, I'm running this kind of mid-journey prompts generating floor plans. And in the end, does this network understand what the floor plan is? Does it understand like what a bathroom is? So according to Jan LeCun, again, the issue here stems not from the inability of the AI model that we currently have, but rather from the constrained nature of the modalities on which these networks are trained. Their comprehensions of language and imagery, while outstanding, it's shallow. And in the end, design, if we think about design, it's ultimately a multimodal endeavor, as an idea can be expressed through various modes such as sketches, 3D models, renderings, depth maps, etc. And this example that I'm showing here, this is an example from the Deep Human Blau network that I'm developing with Kupion Blau, where we have multiple modalities describing different projects. So this idea is more in line, this idea of multimodality and learning through multimodality, it's in line with this idea of intelligence defined by Jeff Hawkins in the 1000 brain theory. And according to Jeff Hawkins, our brains operate in a similar manner. The brain produces numerous models of each object that we interact with using various sensors like visual, auditory, tactile, etc. And these models reach an agreement on what they are experiencing, leading to what we perceive as being the object. And in that sense, the brain works as 1,000 brains at once. Now, according to Kasparov, who's the world chess champion, the limitations of the current AI workflows can be assisted by calibrating the relationship between the human and artificial element in the process. He observed that a weak human player plus a machine plus a better process is superior to very powerful machine alone, and even more surprisingly, is superior to a strong human player plus machine and plus inferior process. Following these ideas, such as the 1000 brain theory and human AI workflow and other previously studied ideas, I began in a way developing these kind of different interconnected network strategies that allow for different modalities and different design agencies to be encoded at various levels in the process. And then this kind of interconnected neural network strategies view design not as an optimization towards a goal, but rather as a multivariable negotiation between various AI models with similar or competing objectives. So here I'm just showing in a way this kind of idea of how you have different kind of networks that have different optimization goals. Some of them interact by being cooperative, others are adversarial. So similarly with these ideas, the DPM-Blau project that I'm developing for Copion-Blau is developing, DPM-Blau is developing this kind of multimodal system that may be automated partially or may automate partially processes and streamline overall workflow, and other nodes that are designed can help amplify intelligence of the practice, which are summed up in these kind of terms of augmentation versus automation. So there are many nodes that address various environmental, technical, or Gestalt topics, with some nodes operating at surface rationalization and panel optimization levels, other working at levels of programmatic organization, real-time environment evaluations, etc. We have different other networks that tries to bring in a way this kind of interaction, human AI interaction, where our designers can query certain results from the network's latent space, or they can use text-based input to generate new solutions. And at the same time, architecture is not just a 2D kind of, or the architecture cannot be solved only to the modalities. So we have also different nodes that address this kind of aspect of 3D, three-dimensionality. So this kind of node-based network of the DPM-Blau project that I'm using here as an example allows our designers then to define task-dependent strategies of interconnected nodes in response to discrete design tasks or specific design problems. In addition to allowing this kind of connections between many nodes, it also enables the combination, blending, and exchange of semantic levels between different nodes. And this augments then the Office workflow by enabling the creation of feedback loops across design scales and feedback loops of interaction between machine and designer within a non-linear open process framework. So as AI models become more and more ubiquitous, it's becoming increasingly clear that the future will not be dominated by a single AI, one single dominant powerful AI. Yeah? The future will be shaped by a collection of discrete, task-specific and domain-specific AI models that interact with each other. If we go back to these kind of ideas of interpolation, extrapolation, one question here is, what are we trying to achieve when using AI model? Are we trying simply to just preserve in a way history? Because most of the data or all the data that you're using training neural networks is a historical data, and then all the results are pretty much based on that historical data. So in this instance, we simply have just an interpolative type of creativity, where you can see what we are doing. We are just creating like interpolations between different kind of Sagrada Familia kind of samples. But what about like extrapolating? Can we go beyond that kind of historical data set? Yeah. So we can engage in this kind of interconnected processes to help us go beyond just an interpolative mode of creativity, where we start to extrapolate outside of the historical data set. Now, for me, these aspects, I start to be also concerned about this aspect of, so how can we grow somehow together the networks, and we as designers, as humans, how can we grow together in this kind of very collaborative in a way process? So that's when I started to look at federated learning, which is a technique created by Google in 2017. And this was, I believe, as a response to Cambridge Analytica scandal. And also European Union started to implement a lot of policy following that scandal. So in this case, federated learning technique allows devices to learn a shared prediction model collaboratively while keeping all the trained data set on local devices. So in this way, decoupling machine learning capabilities or capability from the need to have data stored in the cloud. And always when we talk about data, we are talking about different issues in terms of privacy, who owns the data, who has the rights over the data, and so on. Yeah? In this case, when we deal with federated learning, mostly every single user owns a data set. And in the end, it's just the models that you have, they're just training or using your data set to train locally. I'm going to explain this in a second. So federated learning allows devices to learn a shared prediction model collaboratively while keeping all the data set locally on devices. And what's happening here then, there is a main model that is being created that is shared then locally with multiple devices. So on each device, you just have an instance of the main model. So what's happening afterwards, you have multiple devices that have this kind of instances of the main model. And these instances of the main model, they train locally. When the computer, let's say it's on idle, these models train locally. And then the weights of the networks are placed into a pool, and there is a consensus that is being created in that pool. And then from there, that consensus is being sent up to the main network. The main network is not aware in a way of any, or it doesn't have access to any of the data sets. Yeah, it's simply extracting the weights, the consensus that is being created in the pool. Yeah. So this process then repeats. Yeah. So you have each user using or having their own instance of a model that trains locally, and then all the updates, all the training goes up to the main network, and then the loop continues. So I'm showing this because I know in architecture we have quite a big challenge, and it's very hard to collect data sets in architecture. When it comes to all these kind of image models, the reason why they are so prevalent and they have such a huge progress or had such a huge progress recently is because of social media and the way that we are able to collect through social media a lot of images. But when it comes to architecture, it's quite different. It's quite hard in a way to collect this kind of information. And for me, I'm testing in a way this kind of model in a smaller scale, which is just an office. But my vision would be in a way for architecture, for architects, to adopt this kind of mode where mostly then all architects have this kind of instances of a main model that train locally and then is shared with everyone, rather than going through the task of collecting data sets and then training one single AI model. So I'll conclude the presentation by saying that the future will be shaped again by a collection of discrete task-specific and domain-specific AI models that interact with each other. In the near future, it's anticipated that every single architectural element will be associated with data broadcasting technology. Small AIs embedded in billions of architectural elements, smart devices will interact with other AI and human agents in an ecology of self-organizing agents. What are the interactions rules that will govern this ecology of human and AI agents? How will design be affected in a future where the line between the real and simulated is becoming increasingly blurred? How will design space be shaped when various layers of information like conceptual, social patterns of interaction, material fabrication constraints will be made possible by the availability of a large data set and improved algorithms? And all these are going to be seamlessly integrated in the design process. Thank you.
Thank you, Daniel. It was a beautiful introduction to our third session, actually. We have, as I said, now started the day where we are even, and I mean, maybe this should have been in the beginning of the day, because this is now when we start talking about the more existential issues, the challenges to, I don't know if we want to see it as a challenge or an opportunity of AI for something like creativity. The third session now is we're focusing on the creativity paradigm in architecture and the role of AI here. So of course, architects, they can use AI for creative tasks. You can reduce the complexity of their work and to be inspired to create new things. But of course, also we have to think about the questions whether AI in somehow, is it threatening? I don't know if I want to call it a threat, but is it threatening the creative class, the industry? There's so many questions. Can AI replace the artistic genius, the human genius? Is there even a genius? Is AI art even original? Is any creative art original? There's so many questions we can ask. I want to invite my three first speakers and panelists up here. We have a replacement of one panelist that unfortunately couldn't participate. But Marjan Coletti, who's Professor of Architecture and Post-Digital Practice, the Bartlett School of Architecture, Faculty of the Built Environment. So is he here in the room? He's online, sorry. Online. There's this omnipresence of online. That's good that you're here, thank you. Good to have you here. Andrew van de Moor, Professor in Design Informatics at the Department of Architecture at KU Leuven in Belgium. You are there. Good, so you're coming joining me. And then we have a cancellation, unfortunately, from George Vrakliotis. And we have fortunately been able to move Matthias Del Campo to join us here, Director of R2IL, an Associate Professor of Architecture and Urban Planning from the University of Michigan. And so we will jump straight into the next presentation, and so we'll get a little bit more shape to the debate. This is first we have Marjan Coletti online.
Okay, yeah, thank you very much. Let me try to share screen. Okay, I think you should be able to see it. Well, thanks a lot for the invite. It's a real honor and pleasure to have been asked to contribute to this panel and to this conference. So try to be brief. You've just outlined a few very big questions that certainly I won't be able to answer. I will just try to give a brief account about my personal contextualization of AI and more subjective view and how I try to incorporate it and embed it within a longer and more open research framework. So today I'm going to speak to you as a researcher into digitality, but also as an educator who is trying hard to keep up with different paradigm shifts that are happening, and having taught to Generation Y, currently Generation Z, and very soon Generation Alpha. So surely that's a big challenge, and AI is one of those issues that certainly are to be debated. So we're here to talk about artificial intelligence. Of course, intelligence is potentially a very difficult term to describe. I won't even attempt, and artificial as well. So for the moment, let me replace it and contextualize it as AI being part of a digital intelligence in the way I've researched it. And more specifically about the post-digital intelligence, so going beyond what we know as the digital. In order to do that, let me briefly just use and borrow a metaphor by the late Steve Jobs when he described digital in 1990, so over 30 years ago, based on a paper that I read that stated that the condor was the most efficient animal in terms of locomotion, but that if you put a human on a bicycle, that actually it's the human that has the better values. And hence his understanding of the computers being a bicycle of the mind, something that augments and allows humankind actually to become faster, more efficient, and at the end of the day, we all know what happened. So this is digital. I do agree with this metaphor and in the power of the digital, particularly for architecture. So I've been researching digital now for the past 20 years, and as you can see here, I believe that also there's space for the I in the digital, so for personal, subjective research and understanding. So my research is about this subjectivity and the way how this can actually be nurtured with the younger generations and the students. So the digital as a vehicles. My PhD in particular has looked at the various perspectives and at evolution. So not the digital as a technology, but the digital as being something that is in a wide ecology of interaction. So different chapters look at kind of the evolution, devolution, evolution, and deconvolution of digital technologies within a digital system. So that shows about that actually it's about agility, but also convolution, about complexity. In fact, the term convolution has a threefold meaning. It describes conditions of blur, of overlap, and of interference. And I think these three topics do apply to our discipline and our practice as well. In terms of blurring the disciplinary boundaries, potentially overlapping techniques and references in one's approach to design, and interfering design processes, also by interchanging and working transdisciplinarily with other expertise skills. So the digital to me is actually a symbol and vehicle for evolution and convolution, in other words, for agility and complexity and how to deal with that. So when I talk about the post-digital, I don't talk or don't speak about a condition against digital, but a new iteration of the digital, which is much more complex and potentially much more agile, but also requires an understanding, particularly from our cohort and of architects and designers, to become more agile in dealing with a lot of complexity, and we're here to do that. I would like us to push the metaphor of Steve Jobs, and at the moment I'm proposing the chrysalis as a metaphor of this transition of the digital into post-digital. We all know how a butterfly goes this amazing transition from a neck to a caterpillar, and then through the chrysalis, through the cocoon phase, which totally transforms within a process of holometabolism to a totally different insect. And I believe that right now, after the process of the voracious caterpillar, say digital technologies, to somehow get stuck, or kind of in order to create a pupa, the caterpillar needs to attach itself to a branch, and digital is here to stay. That we have just entered this stage of change, and AI surely is one of those facilitators and agencies that is in the brew of this, in the mix of this brew within the caterpillar that we are finding ourselves at the very moment. And so the post-digital is somehow the wider framework in which I would like to embed AI in my particular research. And 3 upcoming books of research projects that has lasted for 4 years that are going to be published December, February, and April next year will attempt to contextualize this very endeavor that I'm describing. So convolution and evolution are also at the digital, and post-digital is, to me, the vessel for hybridity and metamorphosis that the metaphor of the chrysalis I would like to suggest and suppose. In other words, though, more related to our discipline and to a mode of a practice of actually being architects, I would like to replace these words by the synonyms of, or meaning of, mixing up and scaling up, which we're doing. So my personal way to do that and to find some digital intelligence or artificial intelligence in the digital, not as using it as a tool, but as a vehicle to improve one's agility and to deal with complexity in architecture, was to try to find intelligence and to upgrade to infuse kind of the main vocabulary or syntax of our architectural essence, in a sense, by upgrading them in dimensions. So looking at one-dimensionality, can there be more to be discovered within a digital understanding of one-dimensionality? So if the dot is actually a dot, a digital pixel is much more than a dot. It has far more information, and it's a more complex entity actually to be reduced to a singular essence that has no quality. So in my own research at the beginning of the PhD in the 2000s actually was really about how to extract that intelligence of the digital pixel and to create spatial or to discover spatial qualities that I could appropriate as a designer, as an architect work. So that has informed the way models making or material was then used for the design application. So it became an agent to discover a language that, although it was analog perhaps, had some digital intelligence in it. And the same also to materials. So the dot as potentially a sand cone, how could that actually become an entity in a much more complex and three-dimensional way of capitalizing from that information, of course, for instance, in a 3D print. Could the same happen to the understanding of two-dimensionality? So how can we upgrade two-dimensionality? Or I tried in my own work to humbly find ways of upgrading two-dimensional to 2.5 dimensionality. What if we used the line as the main code almost and the script of architecture, and to understand it not as a divider between spaces or materials or communities in a sense, but actually if the line became a field, if the line became architecture, how would the digital drawing that end up? These are some examples of two-dimensional drawings that, although they're two-dimensional and they're vector graphics, that are not drawings, they're not pictures, but actually drawings, have some quantitative but also qualitative descriptors in it that could be used towards an architectural understanding of what a digital environment might be, though being two-dimensional. And because it's precise as vector graphics, actually, it has this quality compared to an image that the more you zoom in, actually through the accuracy of the vector drawings, the more space unfolds to the viewer. Certainly not a 20th century understanding of proximity of materials in architecture. Think about whitewashing and so on. And again, I tried to appropriate that digital intelligence of the 2.5 dimensionality in a way I would draw, I would describe projects, both 2D and later then as 3D and for projects. Another way through robotics and 3D printing was, of course, also to actually print lines, not only to draw them, but to physicalize lines, pardon me, as real material entities, like here in a project together with fashion designer Iris van Herpen. Of course, you could also extract lines from materials through simple 2D routing or laser cutting or plasma cutting, and again, assemble two-dimensional elements into a volumetric entity, but actually, in my description, still being described as 2.5 dimensional elements. And that would also then gain size and complexity but in their existence, but still conceptually framed by this intelligence of the digital to a 2D that has 2.5 dimensional qualities. Or what if you routed a 2-dimensional actually piece of material like foam, and you, through the process of digital application, might infuse it and entice it with more complexity, but more agility to be performative and formally interesting, but also doable. So here, for instance, a few aspects. Can the same be done to 3.5 dimensions? Then I ask myself, what's a 3.5 dimensional entity? Of course, we all work and are very familiar with volumes and mass and geometries in architecture. But what if the volume is actually subdivided, and if the 3D object is not only an object, but is also a representation of dynamics, for example, dynamics in motion and movement as a representation of a 4-dimensional entity, although not, so what if we're capable of modeling it into our geometries? That potentially is 3.5 dimensional. And we have done it in the past, like in the Baroque. Could we do it again, thanks to this digital artificial intelligence that we might have?
Martin? So think maybe the weird sound is the cue to It's a wonderful presentation, but we have to start moving on to the next presentation. And I really hope maybe if you have a conclusion that you stay here with us for the panel.
Definitely. Okay, sorry, I had to.
No, it's very interesting, but we have to move.
The story would have continued, maybe to give a conclusion to how I believe I managed to achieve 4-dimensionality, 2.5 dimensionality by an interactive system, and into which I would actually potentially put architectural intelligence as well. And apologies if I overrun, I suppose I miscalculated. Anyhow, thank you.
Thank you. And we're looking forward to the conversation after the next two presentation. And the next presentation then we have, we'll go through it, is Andrew van der Moor, Professor in Design Informatics at the Department of Architectures at KU Leuven. I think it's here.
Can I get the first slide?
Can you hear me? Yeah. Apparently this is not the first slide. So you have to go back.
Yeah, much back. Spoilers. I can also go back from the back to the front.
I think there should be a clicker up there. Maybe.
Ah, okay. All right, I'll go to the next one. All right. So I'm kind of teaching already about more than 10 years to architectural engineering students about emerging technologies in architecture. And until 5 years ago, I was telling them their job is safe. Computing cannot really reach the level of elegance and creativity that you need as an architect to kind of solve these very difficult problems when you design, for instance, floor plans. This is a very old drawing, by the way. This is 2015. I think it probably should change a little bit. But this was an article that appeared like 2 days ago. So there's still this kind of the fear, right, that we might give up a lot of our creative power to algorithms. So these are kind of I show them a lot of different techniques that have been developed from the 60s until now, like the Holy Grail. Can we give the computer this kind of design brief, and out comes some very convincing plan. And I think all of these, basically what you try to do is to make some kind of rule systems, or what we just already heard, expert systems. So you try to capture the knowledge that we learned over many, many years in patterns or literally rules, and then you try to make a decision system, which rule to apply and what kind of thing. And so they all have done kind of great work, but even like parametric design, you still have to program everything in what you want. There's nothing coming out that you didn't actually already predict it. And my opinion changed about 4 or 5 years ago when I saw works like this, where you train this kind of neural network based on a lot of good examples, and out comes, for instance, some idea of where to put a floor plan on a footprint, where to put windows, where to put kind of the layout that it should be, and where to put furnishings. And this kind of amazed me, like, okay, you can look at this plan, it's a very bad plan, but it's a plan. And why is it bad? It's not because the algorithm can't handle it. It's just a computing problem. It's not a conceptual problem. So if you look now, like in scientific research, you see more and more papers coming out, and I think it will become slowly exponential, where computer scientists are competing against each other to get starting from the same adjacency graph, like, okay, which rooms do you want to have in your space, and how are they connected, and to create the most feasible and believable floor plan. And this is a paper of this year. This means this is a paper of last year, okay? Because it takes a year until you publish something. Not only that, they're putting more constraints in. They're putting in where you should have load-bearing walls, where do you want to have a window. So it can handle constraints maybe from the structure, but all these rule-based systems can't handle. What they now also are starting to do is, if they have these floor plans, they're asking 20, 50 people, panel of 10 architects, which of these plans do you think is feasible? Do you think can be built? And that's also a measure that they're measuring against each other. That's kind of a diagram. It should be like a bar graph, but that's from that paper, that they try to compete against each other and prove that their system is better than the previous system. And this will go on for several years, showing that this is a competition, it's a computational problem. And so they're adding more kind of constraints, better data sets and stuff like that. But the goal is to get out a very feasible floor plan. And then, of course, you get kind of this kind of more creative or more open-ended solutions that are generated currently, which is also kind of, for me, mind-blowing. You put in some text and it returns a picture that is quite believable. I don't know how to build this. That's another question. I will get to that. But you could, I think, work with that as an architect. And you can say, okay, this is an interpolation of ideas that already exist. But then I wonder a little bit, what are we teaching our students today? We're showing a lot of good examples, and they're interpolating, at least on a student level. If you're a master student, it's something else. But give this to an intern, and you'll get, I guess, some feasible ideas. It can explore different things, different variations. And again, to me, this also shows the point that, in a weird way, computation is bringing back things that I think lots of architects have been deleted over the years. And minimalism, this is the contrary to minimalism, right? So what this computation similarly can do very well is bring back things like ornamentation, embellishments, and this kind of atmosphere, materiality, and I don't know, these kind of terms that in modern architecture, postmodern architecture, I'm not an architectural theorist, but I see, like, if you design with SketchUp, this is not coming out, right? This is not what SketchUp can handle. And this is something on a completely different level. And so what you can also do, on the left side, you see like sketches, for instance. So you can make sketches of a facade, you can make a sketch of an interior, and if you have the right data set, the right system, okay, I realize that, but out comes believable rendering. So think about how long it would take to make a rendering like that. If you have to give it and you have to pay somebody in your company to do that, this thing can do it in seconds, based on a good sketch. You can, and then say, okay, these are images, so they're just images. But actually, if you then start to cropping these images and you give it like the same input again, it actually has an idea of a bigger building. If you crop it again, you will actually see a street. If you crop it again, you will see a streetscape. It's not that it's just images coming out of nowhere. This is what is called a latent space, and it has some ideas. If you give it some input, it will fill it in for you. Or you can actually add people and trees and things like that as well. So what you can see nowadays are companies. This is a company that didn't exist 3 weeks ago. And this one-person company, he already earns 100,000 euros. I think it's his last tweet. I follow me on Twitter. It's a company that makes, you can give it the left image, and you can give it like, say, minimalism, or you say like nature, and it will return in seconds an interior design based on that image that you made, the photo that you made. Imagine you're an interior designer and you have to ask your client, what kind of style do you want? Okay, but how? Okay, and you come up with all these other interiors that have nothing to do with your client. Now you can give exactly that. And he has also done it for landscapes, gardens, things like that, which normally also takes a lot of time. You can give it a picture. You take a picture of the garden, it will fill in the atmosphere that you want. Hopefully this will work. This is also state-of-the-art. There's one guy, or I think there are probably companies doing this, but they're in stealth mode, that shows that these pictures can be meshed seamlessly. So this is a 360-degree. You can look around in virtual reality, if you want, to this kind of landscape. It's also completely made by AI. I'm thinking about the metaverse. Nobody's using the metaverse. I don't know if you saw pictures of the metaverse. It looks like a cheap video game. I want to walk in this, I would say. And if I definitely can choose it, what I want. So you can imagine you are in a holodeck. You put your glasses on, you can even augmented reality. You tell, I want to be in Hawaii. It will create you an image of Hawaii. I want to have more trees on the left. I want this. I want a building of Zahid over the right. It will create it for you on the fly. So the next barrier is to make this in 3D. It's just a computational problem. It has images. It can create images from any angle. So if you create images from any angle, you can get the depth. From the depth, you create 3D. So the previous speakers were, of course, right. It does not have a concept of 3D, but you can create. That's another kind of computational problem, right? So the holodeck idea is not far away. We're living it right now. So where I think it can be, for instance, immediately useful, it's where I call the first head of the long tail of architecture, the thing that nobody likes to design, the thing you get no money for, the garage boxes, the renovations and stuff like that, that you give to interns or people ask 1,000 euros. Well, if for 1,000 euros, you probably can press a button and then you can get a design. You can tell it, it should be done in 100,000 euros and something will come up. And it will be believable and hopefully it will be better than the gray stuff that we see today. You can think about in your company to try to capture your design language, your design details. I guess most companies have some kind of design language, the thing that you believe in and you're different from other ones. I don't know how you do it today. It's probably captured in your partners at the top of the company. If that partner leaves or is ill or something like that, it probably is gone somehow. So imagine you can capture that and your interns are coming in or your people designing can get ideas that are based on your design language. A score comes back, oh, with this design, it's kind of 90% the same as our design language. Maybe you can go ask a partner, this idea, this is not our style, this is a Foster idea. You can think about this kind of implementations in your creativity. The next kind of level, which is other AI systems are dealing with today, recommender systems and things like that, not in architecture yet, is where these decisions, these examples that you get, come with an explanation. So if you, for instance, give, okay, this is a floor plan, and you say, but why do you give me this floor plan? It can tell you, like, okay, your budget was 100,000. Your plan had like this amount of wall surface or this kind of material. You can even do it on a rendering. It's just computation. It will know what if you train it, this floor plan costs this amount of money, and you have thousands of them, it will do a prediction. Whether it's accurate, maybe 80%, but isn't that enough? Do it very, very quickly. But then it can also explain to you why your solution is better or worse. And I think for architects particularly, at least to me, this appeals because in my experience, if you give an image to or a parametric design to an architect, it's very skeptical. I didn't make that. It didn't go through the design process creatively. I'm not taking that. But if you can come with an explanation, you will learn and you can probably make better decisions. So this is, for instance, a study just also came out of this AlphaGo system that was also explained before in the game, where once this AI system came out that could play AlphaGo, the design decisions, the play decisions of the gamers became significantly better. So I hope this also helps in architecture, that you can actually make better decisions, better designs. So the next generation, what I predict a little bit, is maybe you can also train it on neuroaesthetics. This is a field that is really emerging right now, measuring the brain activity, on feelings of people. And then you can also think about atmosphere and moods and health and well-being. Learning how things are modeled. So now they're baking systems. If you give it a 3D thing, it will tell you how to model it. It's the same thing. If you give it a 3D drawing or 2D drawing, it will be able to tell you how to build it. Things that we are doing is kind of skipping the modeling, trying to see if a robot can, for instance, fabricate things that cannot be modeled. I would say on the left one, try to model this. You will spend a lot of time. Well, why can't we immediately make it if we know how a robot, for instance, folds clay? Another thing that we're doing, that's my last slide, is thinking of measuring how people behave in environments by, for instance, changing the environment. So we have like robot walls moving depending on what the activity is, and we will use AI to kind of try to see if we can see the laws of behavior in depending on the layout of architecture. Voila, that was my very quick overview of what can be done.
Thank you. Very brief, but very informative. Yes, and then we have our last speaker here, Matthias Del Campo, Director of R2IL, and also Associate Professor, as I said earlier, from the University of Michigan. And he's been so kind to step in here while he was actually assigned to another session earlier today. But I'm sure he can make sense of also this session.
Thank you very much. Thanks for the invitation to speak to you today. This is a topic that is very near to my heart, so I'm very happy to be here today. I'm happy that this sort of conferences are coming up. Just before I start, this is just a small sliver of the things that I have in mind about AI and architecture. So I'm going to pass around this book here, if you want to have a closer look into other things. You might find in there one or the other slide that is absolutely missing now. Anyways, oh yes, I was expecting that, so this is not intentional, but this is actually my company name, Span. So This presentation is actually a collaboration between, well, I'm a bit confused now about what you see here, but that's fine. I'm going to say what it says here. I'm the director of the ARI laboratory at Taubman College and co-founder of Span Architects in Vienna. I'm based in the United States now. So actually, I'm actually happy no one has asked the question that is the elephant in the room, like why use AI in general? Yeah. And there's actually quite a simple answer to that. It's better to teach machines how to learn instead of how to do things. Okay, what do I mean by that? You've probably seen videos like this before, like the ways how cars were assembled and made until the late 1960s. So you had a bunch of experts who were welding together cars, several people having different expertises along the production line. The first robot that came online in fabricating cars in 1967 was employed, so to speak, by General Motors in New Jersey, and was the Unimed robot. And we are all already getting used to images like this, or videos like this, where we see those assembly lines, welding together car carrosseries and so on. So what's happening here is that everyone who has used a robot before knows basically that you need to there's a pendant that allows you to teach a robot literally what to do. Yeah? Which point in space I'm supposed to go to weld a specific part of the car. And that's what's happened here. Which means also that the car industry has been collecting data points about welding points for more than 50 years. Millions and millions of data points. What can you do with those? Well, you can take those and train a robot instead of understanding the specific point where it has to weld a specific car model to learn what means welding. How can I do it well? So what happens then is that you can actually have an assembly line where every single car that comes along that assembly line is different because the robot actually knows now where to weld. Using machine vision, you can just use that. So this is more from the technical part. Now, another question or another statement I would say is this is the first genuinely 21st century design method using AI in architecture. Why? Well, all these methods that we have been using in computational design for the last 22 years were already developed in the 20th century. Parametric modeling, scripting, agent-based modeling, polygon modeling, NURBS modeling were all 20th century. This method now is the first one that we can apply for the first time because the algorithms, methods, computational power, we didn't even have that 10 years ago. So we can now apply that. Let me give you a couple of examples. The robot garden was a commission by the University of Michigan for Span and basically was supposed to be a testing ground for, or it is actually a testing ground for robots. And the idea behind it was that the robotic department was building a new building and they wanted to have a testing ground next to their new building. And they commissioned us because they knew that we were working on methods that are actually derived from their work. Yeah? Basically, their work at robotics in Michigan is about machine vision mostly, which is actually applied in cars. We used it in a reverse process to design this garden. How did we do that? We actually used a variety of different methods to do this. So we combined different methods. Some of those were style transferring. We used machine vision. We also used deep dreaming. So we combined those things, and there were certain criteria here that had to be fulfilled. A variety of different ground conditions, steps, and so on, because they want to test here the last 100-step problem. I don't know if you're aware of that, but if you want to have robots that deliver things home, the biggest problem is the distance from the delivery van to the entrance of the house, because there's a variety of different ground conditions, there might be steps and so on. So they have to train them to understand that. And so what we did was basically we created a large data set of satellite images of different ground conditions and then trained a neural network to provide us with possibilities of how this distribution on the site could look like. And then in a second process, we applied deep dreaming. We had a data set of fountains, steps, columns. I don't know exactly why we used columns now, but we had it in the data set. And then deep dreamed a variety of different solutions onto that site. Ultimately, I have to say that, yes, the neural networks really gave us a lot of opportunities to use in this design, but still there was a lot of human intervention necessary to get it built. So it's not all automated yet. Yeah? I have also to say that it was an interesting process for us to do through this because it also it actually also raised some questions for us about authorship, agency, sensibilities that are able to be designed with robots and so on. This is just a small segment of the data set we use of satellite images. You need at least 1,500 to make anything work. Now to another elephant in the room, text-to-image generation. You have seen also several examples today. Like even if John Oliver is already talking about Midjourney, it means that these methods have arrived in the mainstream entirely. So one example of an early application of text-to-image generation is the 24 high school project, which we made for a competition in China, where we used text prompts to generate images, and we intentionally used parts of the program asked in that school with some surreal twists to them. Like, for example, this is a gym, it has 1,200 square meters, it has 2 basketball fields, it had changing rooms, and it's standing on yellow legs. Yeah. And the images were very crude at the time. This was before the diffusion models came along, but it helped us to start generating the complete project by understanding how we can use color patches and then basically very simple applications in Grasshopper to create the volumes. But it also teaches us something very interesting, which is that these applications are only able, this is what, by the way, was a so-called attentional GAN, can only help us creating the exteriors, but it cannot help us creating the interiors. So there was not a component that allows us to implement the program. Yeah? So we had to do this manually. You see, all this sort of work, of course, always needs some starting points which are not totally perfected. As Alberto already said, nothing new is perfect. In early 22, we found for the first diffusion models, and I'm an avid observer of media art forums, because they are always the first ones to find these interesting tools. And I started to do things like this sort of endless plan generator, which was done in Disco Diffusion. These new models have something interesting to us in terms of architecture, or the way we architects work. We are so used to versioning, to going through a problem iteratively. Like conventionally in architecture, you take a pen, you start sketching a plan, and you refine it. You do one more, and one more, and one more, and refine, refine, refine. The same also with the sort of working models, like in this example of Atelier Hollein, where there were, I think it's 28 models, variations of volumetric possibilities for a project. What these new models do is they amplify that enormously. I did a little calculation. From April to August this year, I generated 75,000 images in Midjourney. And I'm not a power user. I'm not a power user. So how do these models actually work? Basically what they do is they take images in the dataset and they iteratively add noise to them until they're just random noise. And it does this continuously with millions of images. Right now, Midjourney is based on the Lion dataset. The Lion dataset has 5.3 billion examples of images with text. And what it then does, it takes one of these noise images, and then according to your prompt, it organizes the pixels to create an image. And this is a very simple, this is a simplification, a real simplification of the problem. What does this mean? Okay, take a prompt like this one here, Mies van der Rohe building. So it's getting iteratively better in doing that, and this opens, of course, any possible door for lazy architects, yeah, to just do imitations. This is going to happen a lot. You will see that happen. The other one is it can also be used, of course, more, let's say, inspirational. Section drawing through an opera. And this is actually the version 2 of Midjourney doing that. Version 2 was very different to what is happening now. This is, of course, not an opera section. I mean, if you look closer to it, it doesn't work at all. It doesn't represent anything properly, but it might be a starting point for an idea about an opera. Funny enough, the latest iteration of Midjourney, which this is an image I created last week, same prompt, section drawing through an opera house. So they're trying to become more realistic or more historic, but even more boring, in my opinion. What about this? The most beautiful house in the world. What do you think does an AI think is the most beautiful house in the world? All right. Now let's go for the newest version of Midjourney with the same question. The most beautiful house in the world. Any guesses? Okay, if I see these images, I'm not concerned about the future of architects. So it was also fun for me at the early stages of working through these diffusion models to experiment around and do like really strange things. There's a whole chapter in the book about estrangement and defamiliarization and what that conceptually means for architecture. For example, what happens if you do like a Le Corbusier house made of Kobe beef, yeah? Or a hairy villa, or a house made of feathers. Yeah, I have to, of course, like all these nice tectonic studies. This was rather simple, alpine villa studies and so on. I'm going to go a little bit faster here because I'm running out of time. But one thing I want to say with this here is, one of the concepts that I think is interesting is that we can turn around the way we design. So originally, you sketch something, somebody makes a 3D model, and then it's get refined, you do all the beautiful renderings, and then you go to a client with the renderings and tell him, like, do you like this? Maybe 3 options. Now we can turn it around. We can make 3 really cool images in Midjourney or something, go to the client, and then ask him, what do you like, and then start the work. So I'm going to jump over this because otherwise I'm going to run out. I'm just going to show this one here, the Deep House, as a last example of a client who asked us to do a project based on mid-century modern houses. So as mentioned before already, somebody said that we learn historically from with AI, which is true, but it also allows us to see the latent space between known data points, which is what we cannot see normally. I compare this to basically using a telescope or a microscope to see things we don't see normally as humans, but it allows us to develop our discipline further. So what I did here is basically applying a so-called pixel projection method to get images that were trained on this mid-century modern data set, and then provide the client with a solution for what he was asking for. So all of what you see here was not modeled by us. This was all a result from first images that were created using a GAN, and then using those images to create a 3D model out of them. Yeah, and I think with this is also the end. Thank you.
Thank you, Matthias. And I think we still have Marjan online? Is he there? You have to turn off if you can, please. And will that magically make Marjan appear? Okay. So that was you actually had magic in your hands, apparently. Yeah. So, this was, we've had both a keynote touching on this topic on creativity and 3 amazing speeches. I actually almost don't know where to begin, but actually I do, because I've been doing the same thing with all the sessions today, is to let the speakers just start by, out of all the things that you've been showing us here, what would you say was the biggest opportunity for the creativity paradigm of the architectural sector? So let's take Marjan first, online.
Sorry, can you repeat the question? I think the audio was...
So out of all the many different features and things that in particular you yourself have been presenting in terms of the opportunities for the creativity paradigm of the architecture sector, what do you think, just draw out one key thing that you find as the biggest opportunity?
I think I think the why question is quite important. Fortunately, we don't have time to get to that, but I would agree in a sense. To me, it's a huge opportunity for creativity. So I'm interested in the I in AI, as I said, the collaboration, and if one has an educated a dialogue with it, I'm sure that's something really good can come out of it. That is the danger of laziness, of shallowness, and so on, but I suppose with all tools and all technologies that architecture has embraced. So it's a matter of maturity of the discipline to deal with it. So, but I'm positive, for sure.
So, same question to you, Andrew.
Yeah, is it on? Okay, what I like on AI, what for me was, I thought always a big bottleneck is the prescriptive nature of most of these expert systems. Yeah, so is a prescriptive nature of expert systems. It always tells you have to choose like a 10,000 parametric variations, and then you have to choose one. And I think that's like a big bottleneck for creativity in a way, where these images or these plans or these floor plans or these atmospheres, they're more suggestive, I think. You don't have to take them And so I think that in that way, for me, they're way more creative. And then, if you then can couple it to other kind of things of sustainability and the price, which it will come, it's still not prescriptive. You can still have a lot of choice to make as a human.
So the human in the loop creative process.
Yes, and it's more involved, more fuzzy than all the other rule systems that I know of. Yeah.
And Matthias?
Yeah, so this would be actually a long answer normally, but I would say that one of the things that I think is amazing is that we have the opportunity as architecture, as a discipline, to observe the entirety of our history in regards of what the data that we have, and being able to observe what is hidden within the latent space of our own history that allows us to progress with architecture further into the future. As Julia already in the morning said, AI or neural networks learn from the past, right? They don't produce the future, right? This is then the humans to understand what is the opportunity within that latent space for us to push an idea further in the architecture discipline. Of course, it depends also on the expertise that you have in terms of understanding the tool and pushing the tool in a particular direction, because you have to understand, for example, that if you do like a sloppy curve fitting, you will come up with something that looks different, strange, weird, interesting, maybe innovative, I don't know, maybe creative, yeah. But for us, it is definitely a tool that can push our imagination, yeah, and can definitely help us to embrace alternative languages and ideas of architecture, but we also have to be willing to do that. It's not a given.
So, and then throughout the day, I mean, I've been looking at the different presentations and the different beautiful pieces of, some of them more beautiful than others, of AI representations where I see what we could call creativity, the reproduction of creativity. We also saw in your presentation now is something that we could kind of consider not the most, you know, supposed to be the most beautiful house, but it looks more like something from Teletubbies. But I think that, you know, when you think about art and creativity, one thing that we might also remember in art history is things like Duchamp's Urinal from 1917, or maybe even the Centre Pompidou that some might think maybe is not as pleasing to the eye. It's not, the goal was not convenience or beauty in the traditional sense. So can, you know, is there a danger that this kind of more critical creativity that I would think would also be part of the toolbox of an architect, what kind of influence would AI have, and how do you see like a more, I mean, an interaction that would make sure that this still exists in an environment of architects and the architectural sector?
Yeah, I mean, actually you have to consider that all the processes that we're using in neural networks or AI in general are based on what we understand about our mind, right? I mean, if we understand how perception works, that's why we can do machine vision. We understand how dreaming works, that's why we can do deep dreaming, yeah? We understand how hallucination works, that's why a machine can hallucinate, yeah? But other things like intuition, agency, intuition, sensibility, creativity, these are all processes where, from the neuroscience perspective, we don't know how they work. Thus, we cannot encapsulate them in mathematics. Thus, we cannot use them computationally, which means those things are still going to be around as long as we don't understand how they work. And even when they work, yeah, I'm pretty sure that we'd rather have a debate and a conversation with machines rather than them imposing something on us or the other way around. And I'm actually looking forward to that. I think that sort of dialogue, computational dialogue, can be very fruitful and very dynamic, yeah? And will help us hopefully to solve problems, because at the end of the day, like, there's two things that AI can do really well: optimization and prediction. This is like the main two areas that it can do, right? Which means that apart from the beautiful aesthetical things that we've been seeing today, it can solve things like optimizing floor plans for populations, which mean we can actually increase the living conditions of millions of people using this, or we can optimize it towards sustainability aspects or structural aspects. Even we can include political data, we can include economical data in how those things are getting predicted. I just recently saw a lecture by Jan de Koon, I think Daniel mentioned Jan de Koon too, where he was presenting a new model, which is called an energy-based model, that is actually incredibly good in predictions, right? Now imagine how it would be basically to be able to say, this is going to be the city center of a new city, and then predict to me how the development should look like. Of course, at the end, there's always the human in the loop who's going to say yes or no, but things are going to happen.
Martin, how do you think about, if we have to think about the you could say the impacts on creativity, human creativity as such of AI, do you see any implications that we need to deal with in terms of reaching that kind of future that we're talking about where AI and humans are working creatively together?
Sure, I think, also Matthias mentioned dialogue, it's kind of, it's definitely, I somehow found the mid-journey and the visual dialogue that one can engage in, kind of with these tools. It's really familiar to the way I happen to be working. It's kind of martial arts happens to define two different modes of strategies, the male diagram and the female picture. So this happened to work on the second one. And it's kind of, I always thought that pictures can be extremely powerful strategic diagram for architects actually to deal with complexity and agility. In a sense, this is a tool that kind of I tried, that was my, if I would have finished, kind of I tried to extract a similar mode of engagement with the digital for 20 years. Now it happened to happen through a different technology, and I'm extremely, it's kind of positive about that. That does not mean that, it's kind of, it's the ideal dialogue partner for everyone, surely not. So I suppose some people might want to engage it more in a strategic, diagrammatic way. So, it's kind of AI not as a aesthetic, visual partner, but more as a, it's kind of quantitative structuralist, it's kind of dirigent, let's say, of a co-author process. I think, it's kind of, in a sense, it will work once, or in the cases where kind of there's an equal relationship between, kind of the artificial and the human intelligence, I would say. In order to do that, we need more understanding and more space for experimentation.
So, Andrew, I remember the first quote on your first slide was regarding that architects shouldn't fear for their profession, at least not the creative part. And then there was a little yet. Mm-hmm. So what do you put in the yet?
Yeah. I wonder what the uptake will be in architecture. In my experience, architectural profession domain is one of the most difficult ones to introduce new technologies. Many ships have come, BIM, parametric design, and have passed for the right reasons, I guess. I'm not kind of accusing that. So I wonder what the uptake will be. All the images here are very imaginary, creatively. So I'm not sure of that, if that's that will revolutionize the architectural office that much, where I believe a lot can happen is, for instance, predicting how much it will cost, predicting where the issues will be on your plan while you're designing it. Because then as an architectural office, I guess you can start competing against other people. And I guess that's what drives a bit your architectural office. One side is the creativity bit, but not everybody's, I guess. But that side, which we're not showing right now, there you see a lot of startups happening. And I hope that one at least will come out. Plus some kind of accountability to making buildings more healthy and better, and try to start measuring that as well.
So the creative part of creating or in architecture is also about creating a kind of creativity that responds to social conditions also, and the environment.
Yeah. So having the constraints right now, I mean, that's the other kind of dream that when I started as a PhD student, right? You have one tool, and one first line you kind of sketch, it tells you how much it will cost, right? So, and that doesn't exist because you have to start with a pen, and then you go to SketchUp, and then you go to SketchUp. Every time you have a new kind of tool, and everything information is lost. But this kind of makes it potentially possible that you draw even one line. It tells, okay, I'm exaggerating, of course, but if you have like just a sketch, it can already, for instance, predict where the sockets will be, where the ventilation will be. I mean, all this kind of thing. And that's a major part of your budget, right? If you then put in your material, it will also start being to predict just if you start making one rectangle with one door inside. So you can, and we as architects, I guess we just need kind of a fuzzy number. And all the models that I know of energy simulations, they need precise stuff, you know, and that's kind of always this big fight. This system can actually handle that fuzzy information. So I hope, I mean, it's just creativity images that you can also now start designing within constraints. that are very vital to architecture.
So actually helping with the constraints and then making space for the creative process.
Yeah, it can also give you. It can also give you predictions. Well, while you're starting to draw, it can probably give you kind of, okay, do you want that? That's good solution, and you can ignore it. I mean, it can be fuzzy as an image. It can be just a line. It doesn't really matter, right? So there I see a future, and there I hope it might come.
So let me open to the floor. If there's a question down there. Yes.
We are, all of us are training neural networks. They are learning from us about Le Corbusier, Frank Lloyd Wright. This is the statement. The question is about aesthetic. Do you consider aesthetic in this situation growing with the knowledge of neural network? We are all feeding them. Aesthetic and creativity, an open field or a closed field? This is the question.
I guess this is a question for all. Both Martin also, if you have anything to add. And?
I mean, I could, yeah. I mean,
yeah. Matthias?
I think I didn't understand exactly the last part, but I mean, it's true that, of course, like everything that is now in the data sets is, of course, historical data, so it only can, of course, iterate, or it can only extrapolate from, or interpolate between this data. Actually, it interpolates between the data, right? So there is also a discussion, for example, that neural networks are not able to create anything new. Yeah, because it's interpolating between existing data points, right? So, but there was also, I think Daniel mentioned quickly that it's hard for us humans anyways to recognize anything new, yeah, because our brain doesn't work like that. Our brain always needs a reference point to understand an object in front of him. So if the architecture becomes too strange, you're not going to recognize it anymore as architecture. I mean, I have a whole chapter in my book about estrangement and defamiliarization as aspects of novelty in architecture, and that can do AI really well because it can provide us with things that are familiar enough for us to be recognizable as architecture, but strange enough to make attention, so that we pay attention to it. And this might be the point of innovation in architecture possible, and that of course also creates a novel aesthetic. I mean, some of the images I showed are not conventional aesthetics in terms of how we understand it today. A lot of people don't like them because they don't look like normal buildings, but that's fine with me. I have no problem with that. I anyways think that we overestimate a little bit these sort of things. Yeah. But to your question, I think that if we, it's actually a curve fitting problem. If we don't do perfect curve fitting, we can do pretty interesting things with AI. If we do too perfect curve fitting, we're going to have another Corbusier, another Mies, another Zaha. If I see one more Zaha in Midjourney, I'm kind of puke, yeah, because I'm sorry, but this is something that I don't understand, how people are so obsessed with Zaha. This is crazy, yeah. This is 20th century.
Yeah, to my reaction to you, I wonder what aesthetics is, and if you would be prepared to go on the kind of challenge to have it measured in the brain. So this is neuroaesthetic field is opening up right now, and there are more and more now. The technology before it was like this big thing, like you see in apes, like with all of these cables. Right now it's just like it looks like a sunglass. You can wear it, you can walk around, and they can measure the brain activity quite relatively. Is flat. Okay, it's limited resolution, but they can tell kind of what you feel based on that. Whether architecture is also prepared to go on that kind of challenge, to go more objectively. Okay, you will never get a straight value. Aesthetics is different for everybody, but maybe for your user group, if you have a hospital, it might be with cancer patients, it might be a very specific audience that has very specific demands. So I think that data, from the moment that becomes measured, its numbers, it is again very, very good to put in these kind of systems. And it can probably predict how your audience will react to it.
And emotion detection, I have to add that is kind of ethically something that we should consider, how if we reuse it for other purposes and things, which is always relevant. But this is not the topic of this session, so maybe we can talk about it in the next session. I saw a question down here. Yes, please.
Yes, I have a question that links maybe with the intelligence part of the formula and the examples we have seen presented here today. Yeah, as an architect and also as a teacher, I think like the examples we've seen is more from or just limited to the formal aspect, the looks of the architecture. And this is, yeah, some architects might design just from the image point of view, the form aspect, as maybe our male colleagues in the United States are more focused on in comparison with our more European approach. But also like in the Bartlett in the past 30 years ago, there has been research done by Bill Hillier and his space syntax method that makes or try to develop a link between like the physical existence in reality and actually the social aspect of it that it's generated, the society it's generating, argumenting that actually our architecture is like a mirror of our societies, and he tried to establish the links between it. And I think this is really an important aspect and completely different from the formal approach. What is the societal impact actually of our realizations? We really can manipulate people with space, you know, and that's like a completely different discussion. I do believe, like Professor van der Moer is addressing, that we can, with the aid of AI intelligence, find the shortest circuits in our building for our technical appliances, all the techniques in the building, and that should make our buildings far more cost-friendly, I think. But yeah, so like this aspect, like that you were addressing, only the formal aspect is like we are not teaching our students just to do it the formal way, you know. It's linked to it, but yeah.
And it makes a lot of sense in terms of looking at creativity as also a creative kind or a critical kind of agency. So, Matthias, you have an answer to this.
What's your name, please?
I'm Martien de Maasneer.
Okay, Martien. If I may address you as Martien. It all starts and ends with the data, okay? So if we want to do what you're asking for, we as a discipline of architecture have to create first the data sets that allow us to do that properly, well designed, well made, and they do not exist yet. So it's an iterative process. Going right now through things like text to image, for example. I mean, this is a low-level application of AI, but it's a fun one. So it's actually designed to make people attention to that discipline, to that problem. And then we can discuss, for example, one thing we're doing in my laboratory right now is we're creating a data set of apartment plans from all over the world, annotated by people all over the world, so we don't have bias towards Western architecture, for example, and then can use those to optimize floor plans. Like one of my goals is definitely to be able to optimize, for example, social housing plans, everywhere in the world, because it also has to be locally applicable. It shouldn't be global. It shouldn't be a new international style. The good thing about AI is that we can address those things with the local laws, with the local building code, with the local material properties, with the local specifics of the apartment planning, in order to provide better solutions for living. So this is possible, and we're working on that, but without the data sets, we cannot do it. And we're right now at maybe 2,000 plans that are annotated. That's very, very small for a good data set in architecture. The problem we have in architecture is that we have this tradition of thinking about the sole genius and holding back our data. Like, ooh, I have to protect my plans. I have to protect my sections because somebody could copy me. That's over. So if we want to do progress with AI, we have to tackle that more seriously. And I've tried to talk about this. Okay, I admit I'm a formalist. I love form. It's totally okay for me. But I understand the social problem behind it, the material problem behind it, the political problem behind it. Do not actually put architects who are interested in form into a simple basket. It's not so simple.
Yeah, and I can see that Andrew also wants to address this question.
I don't know if that's correct, but the examples I show to my students are, for instance, in this old research that you show plans of cities together with demographic data, or with criminality data, or with obesity data, or with election data, and it can do predictions It's not 100%, of course, but imagine you can do that while you're making your new square, and it can predict how people will behave in that space. And that comes a bit close, I think, to what you said. So if the data exists, if you can measure it, you can probably also optimize for it.
But I think it's more than just data. Also, it's about the understanding how space works. You know, it's like data. It's the whole how data is linked is also extremely important. So it's about the intelligence of our data, and also the cultural aspect. So it's indeed far more complex. It's like
I mean, I just mentioned before that we're labeling those plans, which means we're inputting semantic data in the information. So it's not just looking at the pixels and putting some stuff together. It's understanding what's a living room, what's a window, what's a wall, and then according to that is able to optimize ways, for example. We can also just take walking data of people within that space, if we have that, and optimize it with this. So it starts and ends with the data. I don't think there's
So we're running out of time, but I actually really understand your question also, thinking that there are things that cannot be datafied and codified, like culture and society. So I think that's maybe also the thing, you know, how can we combine? Before we go to coffee break, we have time for one question, and then we'll move quickly on to have a well-deserved coffee break after this very, very interesting session.
Yeah, so one question asked in the chat. So when AI tools will be available and affordable for architectural practice, so when can we expect AI to be a mainstream tool of design?
So is Marjan in the back still there?
Yeah, I've just been asked in the chat to turn my camera off for...
Okay, so maybe you want to, because you haven't had a chance to maybe comment on this question, and then also maybe on some of the other aspects that we've been talking about.
Sure, maybe. I mean, I agree. I just think kind of the form versus function, or it's kind of aesthetic versus social awareness conversation is not really helpful. It's kind of, I think, we're all engaged in making architecture more adaptable and more self-critical. It's kind of about the environment and so on. And formal, let's say, I think with students, I think the capacity to deal with any shape or form, it's kind of as part of their vocabulary, kind of lets them focus much more on other issues like environmental sustainability, kind of social aspect, circular economies, and all of that. In that sense, so it's just an inevitable manifestation of architecture, and it should be taken as that. The availability, I think, it's kind of students use it all the time, and it's kind of whether it's self-generated or borrowed, so I think it's here actually already. Kind of is for practice to be used. So I don't really understand that particular question. But.
Okay, thank you. I'm afraid we are actually a little bit over time. I don't know if you have some last things that you're burning. I don't want to leave you hanging there on the panel. It's been an absolute pleasure to listen to your presentations and hear this conversation. Very, very interesting. We have a coffee break right now. Let's say that we'll be back here at 15:30. That is in 15 minutes, and then we are moving on to the last and final session of today after the break. Okay, welcome back everyone. We now reach the last session, which is also a very important session, because this is the session where all the questions, and you really have to listen carefully here, very attentively, because this is where all the kind of policy background, the regulations, the ethics behind all of the things that we're working on and been talking about today. If you could please take your place, and also if you want to chat, keep the level at a certain. Okay. Okay, so the legislation, the policy framework of AI use in the architectural system, of course, exists. It's evolving. Even though it's a new technology, then there's several kinds of frameworks and governance frameworks that are meaningful to consider when we're talking about this topic. So EU in particular, and again, we're in Brussels, so it's relevant to mention the European frameworks for this, has really developed a very strong policy position in global geopolitics over the last couple of years. It's something that I've been very involved in personally, so I know it very well. We have regulations on data protection, on personal data. We have the development of an AI strategy. We have different parts of the Green Deal that are focusing on environmentally friendly technologies, the AI strategies. A lot of things, the Digital Service Act, the Digital Markets Act. I'm mentioning a couple of frameworks that sounds all, not all specifically focused on AI, but all part of this kind of ecosystem that is being created now for AI systems and the use of AI systems. Other things that are relevant to also consider when we think about the kind of invisible background of this work on AI systems and AI systems in the architectural sector is, of course, something like the new European Bauhaus that combines technology and art and creation. And so just to kind of make a little bit sense of the background of this session, of course, ethics and laws, they are not just in place to annoy the creative process. It's actually something that we should consider when laws and policies, I don't think I have to emphasize that enough, but they are, at least when they're in democratic societies, they're not arbitrary. They actually are the sign of maybe some concerns or some desires or needs that we have in society, especially when we see new laws being introduced, like at the moment the AI Act that is being negotiated in the EU right now. So of course the new AI and data regulations, they reflects a kind of concern that's been going on, and we've been talking about this topic kind of on the side and also directly all through the day regarding, the role of data, the role of AI, how it challenges some of, Julia was in particular mentioning and showing how it was challenging maybe something we call democratic principles, or also some of the human rights that we have. So of course there's a reason why we now see a very strong position on that in the EU. So in this panel, I would like to invite Emmanuel Di Giacomo up here, that we met earlier, in Elektra Papadaki, who's an architect engineer. She's a team leader for construction and built environment and DG EU growth of the European Commission. And then online, I have with me here Peter Hyttel Sørensen, I have to pronounce it in Danish, I can see it's a Danish name, BIM expert chair of the ACE BIM work group, and Angela Baldilau, PhD architect director of the Observatory 2030. And I would like to, at first, the way we'll organize this session is that we'll first hear two shorter presentations, around 5 minutes each, from Peter Hyttel Sørensen and Angela Baldilau. And then we'll have a conversation where we include everyone, also everyone here and everyone online, regarding this kind of policy position, a regulatory framework that are particularly relevant when we talk about AI systems in the architecture sector. So Peter, I think I can see you there online. So maybe if you would like to introduce with a 5 minutes, just some thoughts on the topic, and then we'll have Angela afterwards.
Yes, thank you. Do you hear me?
Yes, we hear you, and we also see you.
Okay, thank you. Well, thank you, everybody. It's been tremendously exciting to listen to the presentations today. Me myself, I'm not really working with artificial intelligence, and I'm not really working with the design side of architecture as well. I'm an information architect, and that's what I've been doing for many years, creating communication structures for large hospitals projects, as an example, and actually dealing with the also a very necessary side of working with data in the industry, using of course BIM and whatever the tools have been developing in the last 15 years. And I was very surprised by the presentation from Daniel Boulot, and I think it was very interesting because he touched base on some very fundamental issues about structuring data. Because we've been hearing all day that structured data sets are the basic of creating usable tools that can generate things faster and make our design better. But when I look at these foundations, I see a very big difference in structures. I think there are different kind of structures, as Bojan was mentioning as well. We have structures that are based on mathematical systems, on physics, and of laws that are established with science, like astronomy and things like that. And all these things are quite, they can be managed. I don't say that it's easy, but they are manageable in a computer context. It's quite a different thing when it comes to man-made structures in the building industry. To somehow get a grasp of that, I've been trying for many years really to understand how is a perception of things, and I must say it's topics that we do not really understand, and it's also things like languages is a monumental task. We have classification system in each country. We have language. We have data structures that are different. So all in all, that makes it very, very difficult to somehow get usable data. And these data is actually what we need at the moment to make the building industry better, more efficient, and cheaper. We need a good data structure for LCA data and EPDs, which is a big challenge in working with it in practice, and it costs a lot of time. So that's some of the things that might not really have something to do with AI, but I see that it has something to do with the data set that we are collecting. And I don't know, I can also, I would like to end this short introduction by asking a question, because in the construction sector in 2020, the FIEC sent a letter which was endorsed by ACE and EFCA in 2001, where we had some questions concerning when our data are going to be stored in clouds. And you see, there were some general concerns. How can the Commission help us to ensure that the user data are protected, and it's only the owners of data somehow have the right to say what data can be used to. I think it's important that also data should and could be used for gathering bigger data sets, but I think we need some kind of regulation ensuring the data owner, when they place data in bigger clouds like any clouds. And I don't see that we have that rule. And my question is somehow, do the Commission think that these things should be regulated in itself between the parties in the building industry, or is it something that the Commission is looking into, trying to make a simple way to ensure the owner's right to data? Because I don't see it in the data directive and the Data Act. I don't see that this is covered. This is I don't know. This is a question maybe to lead over from me, and maybe could be Ms. Papadakis that could have an answer to that.
So I'll just pass on the word immediately, and then we'll take the presentation by Angela afterwards directly, because we have a representative that might be able to put some frames to this.
Thank you very much for the question, and I'm aware of the letter that you're referring to. The Data Act is indicating a lot of things of how data should be exchanged among different parties, from business to business, business to government, and also what is the role exactly of cloud providers or in general gatekeepers of data. I understand it doesn't cover you from your question, and I think that this is reasonable to a certain extent. The Data Act and the AI Act as well, they are trying to cover all sectors of the economy and a lot of the processes that are happening. It is a first step to organize transactions of data that is the fuel of the economy right now, for many, like, as I said, many sectors. I think it is very useful from now on to discuss all these new instruments, to get comments in practice from architects, from engineers, specifically speaking about the built environment, on what you need to see more and in which space you can work with us more. So this is my answer to this.
Thank you. So a lot of things are happening in terms of data sharing spaces and making things easier for people like that are in this room, that are working with data in constructive ways. So Angela.
I'm not Angela.
Okay.
No, I'm Elena Zucchini. Angela doesn't feel very well, so I'm here on behalf of her.
Okay.
I have a presentation. I try to share the no, sorry, it's not this. I don't know how to do this. I'm sorry.
Maybe we can get some help from the
No, I don't know why I can't. Wait, just a second.
So now something is happening. We don't see you, but we see the presentation.
You see the presentation, okay,
Yeah.
perfect, better. So I'll. So first of all, thank you for having us here today. Can you see the presentation?
Yes.
Okay, perfect. So what we would like to do is to present a website that pretend to be a reference in knowledge, good practices, and data around affordable housing. It's the first dynamic atlas structured with the taxonomy of barriers identified by, by an international committee in which user can play, compare, and access in a unique space of more than 4,000 indicators from the principal database of the world. So the platform is the result of the organization and development of the UEA International Forum Affordable Housing Activation, which has been held last May in Madrid, after Madrid won the candidacy at the UEA General Assembly in Baku in 2019. The forum benefits from the institutional support and involvement of the UEA in first instance, the Spanish government through the Ministry of Transport, Mobility and Urban Agenda, the Madrid City Council, the Community of Madrid, and UN Habitat. So the preparation of the forum and the organization has focused on two specific lines of action. One more academic and one more innovative and technological. The first step was to create a committee of experts that could help and advise the organization and define the contents and the structure of the forum. The committee, composed of more than 40 experts in different fields, not only architecture or urban planning, but also legislation, economics, etc., has identified 6 barriers to access of housing. And on the basis of this barrier, a series of documents have been produced and used for meeting, debate, and discussion in the various UEA regions around the world, and also for the debate and the intervention of the forum. The conclusion of the debate and intervention have been compiled to define a final document that has been presented in Madrid at the end of May and also in at the World Urban Forum in June. The barriers identified are mismatch, policy and regulation, financing, urban design, promotion and production, ownership and tenure. And the barrier have structured all content and brought together specific indicators and tags. So the forum from the beginning has been thought as something continuative, which means that all the content and debate could also be useful afterward. The idea was not that it would be just a simple 3-day forum, but that there would be continuity. So in this sense, we developed a platform that would compile all the data, exemplary case, and debate that have characterized the forum over the months. And apart from the general website of the forum, what we do, the most innovative thing that we do is, as I told before, a dynamic atlas of housing. So in this atlas, you can find more than 4,000 indicators from different databases, official and non-official, around the world, with a timeline series from 10 to 40 years. All the indicators are related to the 6 barriers identified during the forum. So with the data are classified by tailor-made filter as keyword, barrier, font, scale, and of administrative area, and etc. So in this atlas, you can check all these indicators and data, not just by country, but also, that is really important, by metropolitan region. We have more than 13,000 metropolitan region, and you can check all the indicators for them. So you can cross different indicators in the same country, and according to the color that you can see the country, you can identify which is more important or the influence that this indicator has in this country. And you can do this for country and also for metropolitan region. This is a very quick example how it appears. So with this atlas, you can get also the TSN chart to analyze more than 2 variables per city. And it's not so easy to understand, but I think you will do. But anyway, we put an explanation how does it work. And also, we can check the urban expansion. Here we have some example how does appear some place in Spain. You can see the expansion. And also, in this map, you can find, in this atlas, you can find a large number of exemplary cases related to the barrier. And when you click on the black dot, you can find all the cases and you can get all the information about these cases. So this is a really big work that we did. And we did this thanks to strategic alliance and collaborative network that have been established and continue to be established with different entities and institutions, as the ILTI Foundation, Aga Khan Foundation, etc. So to finish, this is the roadmap of the milestone that we have planned. As I told before, we presented the contents in Madrid and at the World Urban Forum, and we want to continue in Copenhagen, Kuala Lumpur, Egypt, and Barcelona. But the most important thing is what we want to do through this tool. We want to monitor exemplary case and good practices, also in rehabilitation and urban regeneration. We would like to identify weakness, promote pilot case, and create new indicators. So the aim of this tool is to be able to contribute in a useful way and to take common steps forward, as technology can help us to create a common space where information can be accessible and when can be shared. And the idea
So thank you, Elena. So this has been really helpful to see, a case study where you're using a lot of data for this housing planning. And maybe I would like to ask Emmanuel also to in terms of in your daily work with the way you work and the technologies and the digital technology and the AI systems that you use, do you have any, do you consider, I saw on one of the slides here with Eleanor, that one of the barriers were policies and regulations. Are there any cases, where you feel in the same way that, or you see the same kind of, rather than being supporting the work, it might be considered too much of a requirement, or rather looking at it as maybe as a guideline?
Yes, it works. Thank you. No, actually, regulation, they are necessary and useful. It's not a kind of barrier for us. Actually, it's we need to work with that. We need to make our software compliant with what's happening. And there was one question this morning about open data. We need to make sure that all the AC professionals will be able to access with security all this data. And we need to make sure that there will be the possibility to have a clear and secure collaboration. And this is why we need to comply with the international security regulation or standards regulation like ISO 27001 or 27017, for example, or SOC 2 regulation compliance. So it's something which also help us to make our solutions evolve. So it's very, I mean, it's very important for us.
So the idea of creating legal certainty is something that I also hear in relation to both the Data Governance Act, the AI Act that is being negotiated right now, and a lot of other policy frameworks that are not necessarily only related to data and AI systems in specific, but are framing the entire, as I said, ecosystem that are supporting systems like and projects like the one we've just heard presented, and also some of the issues that Peter was talking about earlier, and Emmanuel. So I wonder if you could put some view on this and perspective on it from the view from the DG Growth European Commission.
With pleasure, and thank you for the question. Trust is a very important topic when we speak about buildings and construction and the built environment. There is lack of trust between citizens and the public buyers. There is lack of trust between different professionals in construction. We hear very often from product manufacturers that they are very reluctant to release data about their products, and this goes again and again and again. So building trust is really a priority, and this is something that you will see, as I said, both in the AI Act and the Data Act, but it's something also we're trying to do through different initiatives. I think it's very interesting to see what is happening at European level in terms of streamlining the use of BIM. It's not only about speaking about technology, but it's about enabling digital collaboration across all the professionals when we are constructing or when we are intervening in the built environment. And it's really the way forward in a sector that is so fragmented as construction. Very often we say construction is not digital, but construction is also extremely complex. And there we find many, many small companies doing different things that they have to collaborate in order for us to get the final product that is a building or the built environment.
Thank you. This is very helpful. I wonder if there's any questions out here, and we can, or online maybe. No. Well, so this is really I find this topic as one of the most important topics at the moment, because now we're creating not only the technical infrastructure, and as we've heard throughout the entire day, that these tools, AI systems, but in general also digital systems, we were asked earlier also to be more clear about what do we speak about specifically when we talk about AI systems, what kind of models, what kind of tools. So what we're using in build is not just a technology. We're creating entire spaces and ecosystems that, of course, also needs a legal structure. I wonder if we have to think about then the future, and we've been talking a lot about the future, then how, and I could also ask Peter about that. You were asking about, I think, more certainty also in terms of who owns the data and how do we share data. Maybe do you want to elaborate on what kind of future would be kind of ideal for you in your work, in your everyday work, and when we think about the policy and the regulatory space?
Thank you. Yes, it's a very difficult question, because the industry is dealing with a lot of issues, and lately in the Nordic country we've been raising some question to Autodesk, and we embarked on a journey together, I hope, solving some of the daily problems that we have with the software. It doesn't really matter if it's Autodesk or if it's Nemcheck or if it's software in general have a lack of performance that's not really fitting what is expected from the business. And we as a business have a very big barrier to cross with education, and actually getting people to the level where they can perform, moving from a more graphical orientation to a more data-driven approach to the building industry. And I think it's important also to give this, that we need time as a business to adjust, because at the moment there regulation are just flowing out. The CEN TC 442 is now having 67 standards related to BIM and the way that we're supposed to work, and more is coming out, and it's a big struggle for the business actually to achieve these things. So I think it would be very useful sometimes not to think of solving it all, but you need to have a tight focus on the things on the data that you actually have to deliver to be able to control the environmental side of buildings. Now it's very, very important that this is going to be feasible, and it's going to be easy. I know we have databases to extract data, but there are questions about the EPDs and the quality, and a lot of EPDs is still not in a database format, which makes it very trivial to work with. It's very trivial problems, actually, far away from the big idea of the AI that thing can be used. We're standing in somehow in deep mud in trying to solve this transition phase, and I think it takes time. And I also would hope that what we already achieved with BIM, of course, introduction of BIM has changed the business, and it's changed the business for the good, in terms of that it's of course better to coordinate a building in BIM, but it also arose a lot of new problems, because when you get into detail and when you start looking at details and you start fragmenting the communication process in data, it becomes very hard to solve. You need new tools to solve it. And at the moment, people are sitting behind their screens and sometimes thinking they only see what's on the screen. They don't see what's behind the screen. So where do they find things that they don't know? How can they trust data that's not going into the machine automatically, but have to be hand-fed a lot of the time because the systems do not support the data? So I know you can't solve everything at one time, but I think it would be a good thing also to not try to regulate too much, but have a very strong focus on regulation. Should not be too tight. There must be room for development.
So I think so. I heard the word model. You feel you're standing in the model, and very often this is also what we hear. And I mean, in terms of regulation, I think, and maybe you should be better. But of course, I also have, as I said earlier, I do also. I'm the key expert of an EU project that is basically focused on and is supporting DG Connect, and specifically on the human-centric approach to AI. And one of the things is not only on the AI Act, but it's actually also about reaching out in the world in regards to creating a shared frameworks and shared standardization process and shared standards, for example, for AI systems. So I think at least from my point and what I've seen, what the EU is actually doing is that it's not only regulating in the traditional sense, but actually combining a lot of different methods. Maybe I'll pass on the word to you so you can respond on behalf of the Commission yourself. But maybe in the AI Act, there's, for example, the idea of sandboxes that I think is relevant to maybe mention.
Indeed, it's not only regulation, it's a series of measures. Of course, there is regulation, but there is also policy, there is also collaboration among member states, collaboration with different stakeholders, and I think it's very important to engage, but it's also important not to be lost in the different processes that take place in European level. Many of the things that you mentioned, I think, can be discussed also nationally. And maybe it is better that are discussed nationally. You mentioned in a very subtle way the issues of software and smaller companies. You mentioned the issue of standardization. I would add there maybe classifications formats. In the example of BIM that is, let's say, as a work stream a bit more advanced in the European level, we are giving some general directions, but then the countries have to develop the strategies that fit them better, and they have to go into detail. And there is the opportunity for the professionals, either if they come from an architectural association or a technical chamber, to make all of these points, to make the point maybe that they need financial support in order to digitalize, or to make the point that they need skills, or that they need to participate in the dialogue when there are decisions taken for templates, for classification systems and others. And I think maybe this is a better way of working, because I understand that it is very difficult for a professional association coming from an individual member state to participate in all of these dialogues and the AI sandbox and the different regulations and everything. So it's important to break down a little bit what we can do amongst ourselves with other stakeholders in the national level and then in the European level.
Yeah, I think it's maybe also what you were saying earlier, Emmanuel, about not only looking at it. I mean, I think the very word regulation might scare us, and requirement. But as I also, when I was introducing, saying that we should see it as actually a help. It's a way of responding to some concerns and some insecurities. So, for example, the AI Act is about creating certainty in terms of risks to fundamental rights and safety of people. So there is, for example, the idea of having AI systems that are part of critical infrastructures. So there's certain conformity assessments that has to go, but a conformity assessment is basically also protecting the people or the developers of these systems. Because we do not want to create, and I can imagine architects do not want to create something that can have a risk to people or the environments that they're working in. So, Emmanuel, I wonder if also if you could explain more how, for example, the governance frameworks that you're working with can help you in your work.
So I think that one of the key words is certainly communication between all the stakeholders, and not overreacting, when you feel that there is a risk on something particular. I think that this session is very interesting because we all discuss together, we try to collaborate and to find some solution instead of, reaching a point where there is a kind of fire drill and where you try to find a solution. I think that, for example, with what regards AI, there is a big need, and specifically for architects, because it was a kind of subject that was not addressed for, I would say, for years. We need to define altogether some ethics. We see, for example, on our side that in some countries, the fact that software editors are more involved in the conversations with, for example, EU or local governments or BIM task group, etc., is making things smoother and much easier to deal with. And we can try to find solutions all together and not fight one against the others. We need to define solution all together. I think there is also a subject that we did not address so far, which is the next step after AI. We should speak also about the digital twin topic, which is very important. When you see that countries like the UK, even though they are not anymore in the European Union, it's very important because they have decided to create a national digital twin. This was the consequence of a white paper, very interesting one, that they wrote called Data for the Public Good, because at the end of the day, what we are creating as designers or as owners is for the public good. Actually, we want people to make sure that if they have one problem one day, they will know how to go very fast from one point to another, which infrastructure is ready to receive them, which train they could take, etc. We are not creating data and using data for fun. We are creating for a better world. So we need to think about the future. And if we think about maybe a European digital twin, all these subjects will raise, and we definitely have to find some solutions. And we, as software vendors, we also have a big responsibility. We need to be discussing with you on a regular basis, and not only when there is an emergency problem. We try to comply as best as we can, but we need you, and you need us, to define these requirements, these regulations, etc. It's not about blocking one or another. It's very important to collaborate all together and to find some smart solutions. Because if we don't do it as Europeans, you can be sure that on other continents like Asia or other continents, they will do it before us. So we need to be better at that, and we need to take the good examples.
Yes, so looking at the laws, regulations, the entire governance frameworks as something that we create together, and that is actually responding to needs in society as the most important aspect of this. There is actually a digital twin project in Europe, which is very relevant. But even the fact that these projects are being developed all over the world, and there's not one, is also something that creates a kind of confusion. So we need this interoperability, and the reason why we need the EU here is also because we need to actually create a foundation that is based on shared rules, shared values, things like the Charter of Fundamental Rights of the European Union, the treaties. These are things that have been decided together. So better to start on that point than somewhere else.
Just turning back, sorry to interrupt you, but turning back to your question, we have some recent examples in France where the French government has asked to a national organization to comply with EPDs and to make them accessible to anyone and to comply to some specific rules. So you see that we are at the beginning of a journey. So if we would be able to have EU defining some global rules, and that we would be able to inherit from that and work with these rules, that would be fantastic. If you want to calculate carbon emissions, you need to make sure that everybody will be speaking the same language. And we need to know that in order, we have the same questions, as software editors. Most of the time we ask to ourselves, so which kind of EPDs should we be using? And then we will have also, the EU will have the role to ask to product manufacturers to, okay, now that we want to achieve the Green Deal, you have to produce all these EPDs, because if not, we will not be able to do that. And they will be based on digital approaches, they will be using BIM, etc.
Yes, so I would like to give you the last word to Elektra to maybe sum up on some of the. There's been many different aspects, and there's so much going on in the EU. I can see little aspects of everything, but maybe you can give a little bit of comfort and not certainty, but at least something that there's a way forward that supports something that we've been a common goal.
Of course, thank you very much. Well, first of all, I want to thank you for having me here. My professional life is composed by me speaking about construction to lawyers and economists, so you can imagine. And today I'm here and I'm really opening my mind in different areas. I think it was very interesting that we discussed, was discussed before also, all the idea of aesthetics behind technology. Now, in our work in the European level, we have to come down to the ground, and from one side to set some common guidelines for things that are very important, like the sharing of data or the use of artificial intelligence according to the ethics of the union. But we're also like looking on the ground to solve small problems. We have projects on BIM, we have projects on the digitalization of building permits, on digital building logbooks that are also setting the ground for data availability about buildings and infrastructure in the built environment. And there is work in all levels. And there are a lot of opportunities for dialogue. You said very nicely, Emmanuel, that we are in the beginning of the journey. And if I have a final word, is to invite you in your level, in the European level, national level, in the level of your company, wherever is your maneuver, to participate in these debates and help to make this transition that is going to happen in any case as good as possible, as beneficial as possible for your businesses and also for your society.
Thank you. I just want to thank the three of you, the four of you. I think we lost one of the speakers online, but at least we had her contribution. This was at least, we cannot create any certainty or provide any solutions, but we can have an open conversation about that, and things are moving. I mean, I remember working 2 decades with data ethics and AI. Well, AI ethics came later. That things have really changed, and there is a very strong position in regards to creating some certainties for people that are actually working with data and these AI systems in their everyday life with a very open attitude compared to, I think, a lot of other regions in the world where policies and regulations are not created by everyone. So I see a positive future in that sense. So thank you. And we'll quickly move on. So we are starting to get to the end of the program of today. So we are getting there, and everyone is so brave, and I actually still see alert faces, even though we're at the end of the day, and we've had so much interesting input today. And maybe it was a little bit, what can we say, to put the regulation and ethics at the end, but next time we'll put it at the beginning, at least I'll suggest that. Here, I just want to introduce Pavel Martinek from the Architects Council of Europe, chair of the practice committee, who would like to present a study based on, among others, all the input and the ideas that was received at this conference.
Thank you, Guy, for the floor. Can I ask for a presentation? Yes, so I would like to remind that this conference is not only one action that ACE is organizing, that we are going to organize also research that should follow up this conference. This research is intended for around 10 projects, and we think that it's best suitable for students, for young architects, but also for organizations and universities. So for this research, we have overall budget 20,000 euros that we will divide equally based on number of selected projects. And we think that this 10 project is around maximum. Also, I would like to add that there are no any professional requirements, and the research will be in English language. Objective of the research should follow topics that we heard today, but we would like to go into a little bit more detail. So at the beginning, it would be AI in urban planning, because we would like to study some consequences about the new methodology and so on. Then creativity and practice. Separately, we would like to focus on AI on education of architecture, because this is something what hasn't been presented today very much, but as a role of architects and his responsibility is changing, it might have also consequences how we are teaching architecture. Another topic is concerning AI and sustainable approach. Today we heard several presentations which were very close sustainable assessment, so this is also a possibility. And the last one is concerning regulation and ethics, where what is very close to our last session, and databases, also copyright rights and other things. And particularly, I would like to mention that responsibility for algorithm, that is every time very necessary to know what is behind of outcomes. So these objectives will be in detail described on document that will be on our website. So this document has a name, objectives and context. So I think that within weeks you can find it there. I would say a couple of words about what could be submitted and how submission would proceed. So of course it is mentioned for proposals for a new project, but not only for them, because we understand that amount of money we have to divide, it's more like stipend, so we also welcome any ongoing project in progress. So it's a typical for diploma students with a diploma, so they can submit their project and we can evaluate it, whether we will support it. And of course, there is one, let's say, condition that we would like to know whether this project is supported or if there any third party is engaged. It automatically doesn't mean that that project would be excluded, but it's good to know, to have in context that the project is developed also another way. And finally, the sum of submitted project will be selected by as jury. The timeline of that research, we are trying to follow up study year, so we would like to catch spring semester. So now we are in time within weeks to announce beginning of research, to get submission end of January and make decision end of February. And then there is a deadline to preparation of project. The final deadline would be September 2023. And next General Assembly at autumn, we think that there would be some brief presentation. Also, we have a budget for publication of these projects, research, pardon, sorry. So, thank you very much for your attention.
Okay, and so I am ready to hand over the last concluding remarks to Rolf Schagerman, the president of the Architects Council of Europe. And Diego also. First Diego, okay, so we take Diego Sobby, Architects Council of Europe Executive Board Member, as the first concluding remarks, and then I'll pass on to Ruth then at the end.
Very briefly, thank you. I wish, first of all, thanks for all the staff that organized this conference. First of all, Pavel, Martinek, Pierre, Julie, Deutschmann, and all the AIS staff that participate in these efforts. Just to, I received breaking news 5 minutes ago that's saying it very briefly. Ursula von der Leyen announces new Green Buildings Academy. I'm pleased, she said, I'm pleased to announce the launch of a new European Bauhaus Academy, which will have 3 priorities. First, to promote green and digital skills in construction. Secondly, we are increasing funding for research and innovation in these crucial areas. And third, the new academy will have a strong digital orientation. So I think that we are perfectly in coherence with this proposal, and we are very happy. I wish just a thought. I start with the first slide in the morning of Julia Aldwin, the past as a promote, because after this enormous, huge image and suggestion that we and proposal in communication of today, I wish to avoid any trivial comment, but I think that it's a tool, but it's a very, very power tools. I don't know if like wheel or very simple like a new device that changed not only our life but our mind. And so basically it's a new language and has in the past Greek and then Latin and French and English was used for trust, for culture, to disseminate all our knowledge. I think that artificial intelligence is a new language. And so from a political point of view, I don't anticipate the intervention of our president, but I think it's very important to continue in this process and to go on in the research announced by Pavel before, and in other step, just to create a strong connection between our profession, architecture, and digitalization, I think. Thank you.
And here we have Ruth Shagerman.
Yes, dear colleagues, I really have to say that this was an enlightening and inspiring conference. On the topics, it's not so easy to get an approach to it, and I think today we really got a perfect overview on the different perspectives, and also we had great presentations, and I'm sure it will go on as this topic is of relevance not only for our profession but for the built environment and also on European level, we heard today. Lessons learned, just very briefly, these are my lessons I learned today. Others might have learned other lessons, but let's say I took with me, humans bring the future, the computers bring the past. I would always have thought it is the other way around, but no. Infinitive possibilities to analyze, but there are still limitations, so not everything is possible. Speed of knowledge, everything comes back as quick as you send it out, so the interaction is much quicker in future. Change of design procedures are necessary. Inhabitants that have an impact on the design can be defined either through existing data, was not clear for me until now, or through defining codes. Sensibility and poetic is possible. Parametric and artificial intelligence, they inform each other, and then magic happens. Feels quite human. But human creativity and combinatory creativity are different. Open sources are an opportunity, and regulations are changing in the EU. So open sources versus data protection, in which direction will we be heading? Now we will have the possibility later when we go out, for those who are here in the room, we will see what our colleagues in Czechia have created. Jan Kazal, the president of the Czech Architects Chamber, will give us a short introduction outside in the lobby. And then he will invite us to a cocktail that we then can enjoy together, and I'm looking forward to that. Additionally to this, we have an exhibition on European projects with the title Strengthening the Security and Resilience of At-Risk Religious Sites and Communities. It aims to advance the protection and safeguarding of European places of worship by design. And now I really have to direct my word to Gray, because Gray, we are extremely happy that we could convince you to be the master of ceremony today, bring the whole program together, manage the timing, putting the right questions on the table, and you are a capacity in your own rights. So thank you for your time, spending the whole day with us, and we appreciate this very much. So thank you for this. And I also have to say thank you to all the speakers, because you gave all your knowledge and your wisdom, let's say, in very short, impulsive, and interesting presentations that we are going to harvest from, maybe saying it like that. So then I also want to thank again my colleague Diego Zoppi from the board, who was really participating as a brain, together with Pavel Martinek, chair of the practice committee. Thank you for developing and executing this great conference. And then obviously, a big thank goes to the whole ACE team in the office for merging an idea into reality, what happened today. Thanks to the technicians in the back, thanks to the translators for all your patience, and thanks to whole audience, the audience here in the room, the audience online, for your patience as well, for participating with your questions, and thanks to everyone. Enjoy the cocktail and enjoy architecture outside. Thank you very much.